in. Okay, we're completely shifting over. And the reason why, mainly, hold on. The reason why is, it's mainly because it's fun. Okay, this is going to be, we'll just see how it goes. This is going to be the bottom plate. It should, why doesn't it just have, it should use the system one. Okay, so the first thing is, but does this cycle through? It's weird that you can't just, the hell? Wait, what? Oh, wait. That's kind of weird. So what you have to do, you have to go circle this, you click. Now this is ready, but you can't just start typing a variable name. So you need to type 1, then you need to do this. That's kind of silly. All the way down here, customize toolbar. I'm gonna go put on shorts, I think. Yeah, it's already warm outside. Let me just sketch out. Dude, we're starting fresh. I realized that there's such a big advantage to starting fresh. So we're gonna start the code from scratch too. We're gonna make a new repo. We're gonna do all of that because it's just so, there's just too much. There's too much going on. I need to shed some fat. So bottom plate. Top plate. Let's. I'm gonna see if I can do this in like 3 hours. Without the hopper. What if we just move? So I can. So wait, hold on. I can just move this in here. I don't get this, dude. Okay, whatever. Let's just get used to. Wait, hold on. I want to customize this. I want S to not be. I want Alt C and S to be switched. Oh, measure is this? Okay. Where is just S? First off, why is this? Okay. Whatever. Where is the S? You can't change this, dude. That's so ridiculous. Okay, wait. Let's just try to do this then. That sucks. All right, whatever. I'm just gonna get used to it. Fine. Oh, maybe I should wait. How do you delete this? That's so weird. How do you do it? Plate diam. And you click enter, and then it brings you to. Oh, okay, so maybe this is the way that you do this. I think it's 50. $55. Doesn't really matter. What we do want to do though is we want to insert. We want to. Yeah, import. We want to import. Yeah, it's probably not going to be in here, but I think I have them in the docs. So wait, let's keep code open, and I'm going to make a new repo, and this is going to be the actual project. No, I don't need to do that. We're just going to keep it in here. Part docs. It's probably not this. Okay, we might as well fix this. So, was that Nima? It's probably here. The thing is about this. Did I like it? No, just the BLDC. Where did I get the? Oh, you know what? I got it from the official stepper driver pinout. It's stepper driver pinout. You know what I did? I got it from this But then something is weird. Okay, so let's go to pictures, 3D downloads. Okay, great. So now we want to upload that. Pictures, 3D downloads. Important is combine it to a single part studio. Okay, wait, but how do I... Oh, here. Okay, but the interesting thing about this... Wait, was it with this one? I'm pretty sure this thing has like 1,000,000 bodies in it. So what we need to do... Or actually, I want to... Yeah, I want to import the other way. Oh. It's all one part, which is not great. So if we were to do the same thing in Fusion... Open? I think it's just open. Bro. But so if we go here... Oh, wait, there's one body? Wait, what was the thing that had like a ton of bodies? Okay, wait, so we okay, so we're good. We can close this. Okay, whatever. Let's just edit this one. This is gonna be the real one. And what we want to do is split. Okay, wait, so let's just make sure we know how to do it. So in here, body to split, splitting tools, it's gonna be this. Wait. Split body, body to split this, select. Oh, wow, I'm pretty used to, Oh, that was it? Okay. So then we shift J. Oh wait, we have to okay, so this is what we do in here. I'm just remembering how we do this. So this is shaft. Maybe I could just export this, but I feel like I want to know how to do it in onshape. So this is renamed to stepper. So now we do shift J, this and this, and wait, hold on. The shaft we unground from parent, then we ground this to parent, then we select both of these, we do a shift J, then we do this and it's revolute, and then type snap. Okay, so that's, and then this is a, and then I think we rigid group them. I think that's it. I think we're all good. So now we just need to know how to do that. Okay, that was really easy. So now we want to, but then this can move now, or what? Um,
So in our last video, we brought components together from different parts studios into an onshape assembly. Now we're ready to create mates between these components so we can establish dynamic assembly motion, meaning we want the lid to hinge open and close at 90 degrees. Now, mates work a little differently in onshape than they did in SolidWorks. In SolidWorks, what we would do is select two faces and mate them together. Well, in onshape, things work a little bit differently because we utilize what are known as mate connectors. Now, a mate connector is kind of like a coordinate system. It's got a location and it's got an X, Y, and Z axis. And each component that we're mating together will have one of these mate connectors. So when we mate these two components together, we could say we want the X-axis and Y-axis and Z-axis to perfectly align. That would lock those two components together. Or we could say that we want to establish some degrees of freedom while locking down other degrees of freedom. Like in our assembly, we want the pin to be able to rotate 90 degrees so the lid can open and close. Well, in today's video, we're going to show how to create these mate connectors and how to establish the relationship between mate connectors in our assemblies. So here we can see that we're in our assembly in onshape and our components are free to move around. We'd like to start creating mates between these components, which means that we need to start creating
so
mate
the
connectors.
interesting thing is that when we did split body, wait, let's go back. Oh wait, no, it is free to move around. Is there such a thing as an as-built joint? Is there such a thing as an as-built joint in onshape? As-built joints like in Fusion 360. Okay, so Does it matter the order? Hold on, I'm gonna...
Because we don't mate between the faces of our components in onshape, we mate between mate connectors. Now, a mate connector can be created manually, but they're most commonly created on the fly once you enter the mate command. So I'm going to start out here by going to the revolute mate command in my onshape assembly. And now we see that as we move our cursor over the different faces of this model, these mate connectors show up automatically. In this case, what onshape is telling me is that if I click on this planar face, a new mate connector will be created at the center of that planar face. In this case, what onshape is telling me is that if I click on this edge, a new mate connector will be created at the midpoint of that edge or at the end point of that edge. The cool thing about mate connectors is that they will update dynamically. So if the geometry of this edge were to get longer or shorter, the mate connector will relocate so that it is always at the center or the midpoint of that edge. So what I'd like to do is create a new mate connector here at the center of this end face of the pin. Now we see that when we create that mate connector, it does have an X, Y, and Z axis. I'm going to create another mate connector here by selecting this circular edge, and onshape is going to create that mate connector at the very center of that circular edge or coplanar to this end face of the hinge. Once I select that circular edge and the mate connector is created, we see that onshape moves those two mate connectors together. And what the revolute mate does is it establishes a coplanar relationship between the X and Y axes. The X, Y of each mate connector creates a plane, and now those planes are brought coplanar, and a coaxial or coincident relationship between the Z axis of both of those mate connectors. So once I hit the green check mark, we can see that I can take this green component and move it, and this planar face and this planar face remain coplanar because the mate connectors are hooked together. And we can see that if I were to take this component here, the pin, and rotate it, that the two components remain coaxial or concentric. Again, we're not mating between the faces of the components.
Wait,
we're
why
establishing
is it
a relationship
moving?
between the two different mate connectors. But as we can see, having that Z axis completely free to rotate is a problem, and this component is not properly aligned to the green component. So let's use Control Z to undo that mate. Just Control Z a couple of times here. There we go. Now that mate is no longer here in the tree. And let's once again create this revolute mate. Now, some of you may have noticed that once I selected this planar face of the pin and then selected this circular edge of the hinge, the two components were brought together, but it looks like one of the axes is not aligned properly. And onshape has a solution for that. We've got this button here which says reorient secondary axis. So anytime you've got components that are misaligned by 90 degrees like what we've got here, you can use this button to rotate that component around until it is aligned properly. The other thing that we're going to do this time is we're going to choose this button for limits. And we're going to say that the Z axis rotation starts with a minimum rotation of 0 degrees and ends with a minimum rotation of 0 degrees. Now, I know that for some of you onshape pros out there are different mates that might be a little bit more elegant to establish this relationship, but I wanted to use the revolute mate twice in this video, and so that's why I'm using it here with a 0, 0 for axial rotation. So I set that to be 0 degrees of axial rotation. I hit the green check mark. And now we see that once again, when I move the green component, these two faces are remaining coplanar. But we also see that if I were to rotate the pin component, that now both of these components rotate together. And that's exactly what I want. So I think I'm ready to move on now and create a second revolute mate. So once again, I choose the revolute mate command. This time I'm going to choose the pin, which we see it's a cylindrical face. And onshape is going to create a new mate connector at the center of that.
Okay, so what I'm going to do, let's do it at the end. So we're going to do a mate. Oh, wait. What is the revolute mate? Wait, revolute mate is M. Oh, you just have to... And then we want to, okay, wait, but I want to go to here. And wait, which did we actually... Oops. Which did we actually pick? Oh, it's Alt-T. Wait, how do you do this thing? How do you change tabs? Whatever. Oh, it's going to bother me, though. So, wait. M. Why isn't M working? Oh, this isn't the assembly. We're going to undo this. So we're going to mate revolute the top of this to there. That's the end on that plane. So what we want to do is now move it up from what the original distance was from here to here. And that's 22. So I wonder if in my variable studio, can I actually, like, if I go back to this, I select this face and this face, I can add variable for this measurement. And the name of this is going to be top stepper to shaft end. But now can I move that into a variable studio? Because really I want that in variable studio. But anyway, so we edit this thing and the offsets, the Z is going to be oh wait. Is there a way to keep this synced? I actually don't know. Oh wait, this just is how it is. Okay. So in this assembly, we edit this. And this Z is gonna be shaft. What is it called? Do I have to save it or something? New part studios. Okay, wait, so let's just close this one. Okay, so insert this here. And then we are going to do a mate between this and this. And then we want to offset and this is a revolute, and we want to offset this by... Why don't we get this,
Designing complex parts and assemblies in Onshape.
Wait. Oh, it's just because we didn't even define it. It's just because, like, I'm being dumb as hell. So this is going to be... And then what I also want to measure is actually in here, we also want to measure... This is just 24. Okay. So, wait, so stepper face to shaft. So this is just going to be called shaft height. And this is, and then this is going to be stepper notch from face. And then, okay, so then this is going to be 24. And this is going to be stepper notch. And this is just going to be 2, right? So that makes that, let's just check that that's right. 22, perfect. So now when we do this revolute mate, this is going to be stepper, this is going to be shaft height minus stepper notch height. Okay, but the interesting thing is, yeah, this is why, in some sense, I actually really like Fusion not having a difference between assemblies and whatever, because okay. How do you play it though? I thought can't you just click and drag it? Can you ground this? In Fusion, there's a notion of ground to parent. Is there something like that in onshape? In onshape? You can right click a part and select fix. Oh. Oh, there we go. Now we get this thing. Okay. So can we move this to its home? Because I moved it around. Let's just start from the beginning. Insert this in its default position. Shift 1, Shift 2, Shift 3, Shift 4, Shift 5, Shift 6, Shift 7. And then how do you, okay. Oh, this doesn't rotate you 90 degrees, but that's fine. So now we're going to do a mate between here and here. Offset, revolute, Z, shaft height minus notch, stepper notch height. And then what we actually need to do is we need to go into variable studio, and we need shaft height to be replaced with stepper shaft height. Okay, so, and then that's it. That's the whole assembly, right? Oh, and then what we want to do is we also want to take this body and fix. And then is there a notion of capture position, revert position? What is the analog for capture versus revert position? Okay, well, let's not dig too down the rabbit hole. But the thing is, will we be able to use this assembly in Part Studio? That's what my question is. Maybe not. Okay, wait, so we want to delete... Wait, oh, you just click them. I actually like that you don't have to hold control down so much. Wait, so let's just start from the beginning now. Okay, I gotta go to the bathroom. All right. So, okay, it's 5. 5 for top. Shift 5 for top. I don't get, I feel like I'm missing something because there's no way that you would, because most of the time you're going to want to put in a variable name. But whatever. Oh, and we need to change this to bottom plate. It was 55. I don't remember why I made it taller. Oh, and then we're gonna need to put that notch in there. So it's called yaw. That's right. So let's just do a playthrough. Wait, this is a playthrough of yaw. But what do I want? Do I still want to do this? I definitely don't want 8, but honestly, 8 would be better. I'm gonna. Um. I feel like, but I'm pretty sure that this is wrong. First off, this is a 3mm plate. A 2? Yeah, this is supposed to be a 5mm plate. So there's a whole bunch of like bugs and forgotten things. Pillar height is not the. Oh, it's funny. It's kind of like a lean proof. It's very hard to, because if I said, it would be like, it'd be like that left mole left add type of thing. This would be like, um, top of bottom to bottom of top. Um, or what if I just did, yeah, what if I just did plate distance, top, bottom, plate distance, and then this, I mean, what do we have it as here? See, the thing is, this is all wrong because you can see this gear is not meshing perfectly. But okay, well, let's just say it's 31. And then this is the top of the bottom plate to the bottom of the top plate. And I wonder, actually, we should do a little test because in a normal code editor in an IDE, if we were to, how do you, oh, this is the most annoying feature, is that you have to do one and then you can start typing variables. And so if I do top of, interestingly, it doesn't give me a doc string. I feel like they could easily make it, like if I hovered over it even, but anyways, not a big deal. So then, what is, so yeah, so let's just look at this sketch now. It's a 10 millimeter hole. So let's just go to variable studio. And this is, I really don't like that. But okay. Okay, so yeah, so now we can do the, oh, it's kind of hard to actually get it. Okay, so you draw this circle, and now I should just be instantly able to start typing. Oh, wait, that's sick. Okay, you can do new variable in here, but it doesn't. Wait, is that, do you just write an expression? Presumably you can just write, wait, okay, wait. When we go out of here, let's finish this. That's great. Okay, so I didn't recognize that the first time that we did that. But if we want to go to variable, this is all you have to do. It's hash identifier equals expression. So in here, when we're doing this, we could just say hash foo equals 5 millimeters. No? Is that because of this? I mean, wait, why doesn't the up key cycle through? That's actually really annoying. What if I just do new variable? Okay. Oh, okay. All right, wait. So wait, let's see. How does that work? Okay, so I just say hash center bolt. Okay, equals, yeah, 25. Enter. And then if I, okay, let's draw another circle. So you have to you draw the circle to the extent that you want. You click down. Now you're in this mode, but you can't do hash because hash takes you to, yeah. So what you have to do is this hash foo. Okay. It's starting to make sense. But the thing is, okay, because whenever you learn a software like this, you kind of have to think about how were they intending me to use this? Because it feels like the workflow is not to just put everything in Variable Studio, but I feel like, what does this do? Oh yeah, so but without the, but so I don't know. This should, like, if these are exclusive, whatever. Okay, so this is going to be a center bolt diam. was the last one? Okay. So now we extrude this by wall. And then, okay, and then let's just get fast. Okay, see, this is bottom. So we're going to draw a circle on here. Click one, this, plate diam minus wall. Extrude. That's going to be an add, and it's going to be bottom plate height minus wall. Great. So we have that. And then what was this? Oh, this is some weird thing. Should we design the pillar? It's hard using both panning. Yeah, so it was all a project or something. I don't know. Why don't we... Do we need... I think it's better if we don't do an indent. I'm going to try no indent and just holes. So all we need to do is then draw circles, circular pattern. Okay, so let's do that. So what we need to know is... But how do we know? Oh, is it this sketch? No. Yeah, that's weird. How do we know what the distance here is? Okay, can I just draw a sketch on this plane? Revert position, and then I want to hide everything. Oh wait. This is what you do. I can't believe I didn't learn this. You type V. V is the pro strat. So I'm gonna project this. We get these circles, and I want to draw a construction line from here to here, and then a distance measurement from here to here. Okay, so it's 5 away. Okay. So what we're gonna do is draw a sketch on here. A normal. And we're gonna draw a circle here. And we're gonna make everything a freaking variable. So I do 1, and then I do but you have to put hash, okay? And it's going to be pillar hole diam. And I think it is probably like 150. So it is a little bit annoying that, because I just want to make everything global, but whatever, let's just keep going. So then from here to, oh nice, we get this automatically. This is going to be pillar hole, oh. Wait, this is 1.5? No, it's not. Oh, wait, did it define it, but not, oh no, it should have. Select the mirror line. Select the entities mirrored. Great. Has it been done? Yeah, it's been done. Okay, so now we extrude them and then we circular pattern them, and then that's it. So we're going to take this. Wait, what? And then this is how we do it. So you don't click on it. So yeah, you just got to unlearn things. Okay, but that's fine. Wait, what? Oh. Yeah, okay. So you have to switch it to remove. So we do that. Now we do Alt-C circular pattern. Entities to pattern. Can I do this extrusion? New, remove, entities to pattern. I can't do features. What? In Fusion, I can do circular pattern and then click on features, but in Onshape, when I try to do circular pattern and then click on one of the features in the timeline, it doesn't do anything. How do you circular pattern a specific feature? Wait, does it have a thing? Did I just totally miss it? Oh, bro. So I feel like this dialogue is hard to read. And I just click this, and I say the axis of pattern is this. And the instance count is 4. Okay, yeah, we're done. All right, great. So now we have that. Okay, now we need to... Okay, so... All right, so what is required with bottom plate? We need to just add the pillars and design them. Then we need to add... Oh, we'll get into gears. This is going to be fun, man. We need to add the stepper, the hub. Okay, I know what's going on. Okay, so um in Onshape, when should I make a new part studio tab versus just try to make a part within a single part studio? Deciding on whether to create a new part studio tab or add parts within a single part studio depends on the complexity of your design. If the parts share references, need to be designed together. It's more efficient to create them. Yeah, it's just one of those questions like in software development where it's like, how abstract do you need to go? It's a very complicated answer. So, or it's very, yeah, it's dependent. I think we could. So we're going to do the pillars right now. And okay, so, and what we're going to do. Uh, are aliases bad or good? I mean, they'll update no matter what, but okay, so let's do this. So we're gonna sketch on here. Wait, yeah. Oop. I'm gonna draw a rectangle. Ooh. Okay. Then do we get to use this? We get to use this. So let's okay, wait. So pillar footprint is 20. And then what the hell is going on here? I'm pressing enter. Oh, why does it always do that? Why doesn't it? That's wild. I don't really get that at all. So we're going to take this plane and we're going to extrude it by wall. And it's going to be a new. Okay, then we're going to draw in here, sketch, and we want to know, finish sketch. We want to edit one of these pillars. Hey, yo! It's 12, and let's just look at this first sketch. Is it centered? No, it's not. Okay. Um, wait, no. Oh. Oh yeah, create variable. Wait, 12.5. This thing is 20, right? Oh, to the center. I want to keep that defined, but I want to delete this. No, no, no. Wait, what? Pillar to y-axis whole side. Okay. And then this, I think, should just be driven, right? Wait, it's it's easy to This is over constrained because somewhere hidden in here. What is that? I wish it would tell me what that is. How do I see what? Okay, well, I think it's fully constrained, right? So, okay, so we can extrude this now. And so, total pillar height, and then so we're gonna, oh wait, so we're gonna extrude this. And it's gonna add, it's gonna be, it's so weird that, okay, well, actually, this is fine. We can just make this snake. Total pillar height mass wall. Okay, and then you fill it. What? Oh. And it's going to be pillar diam over 2. Making that 5 and 5. Yeah, we'll use the M2 by whatever's. And then now we want to do another circular pattern. And we want to pattern parts around this. And if can I just move these? I guess they're locked down, but I don't know how to tell how they're locked down. Something that I always forget to do is like when you're defining the variables, you want to define them for what they actually are, but then it's so much more convenient to define them with clearance because that's what you actually want to use. But anyways, I always forget to just add that intermediate step of you make 2 variables. One is the actual dimensions so that you can like refer to it and remember what it is, and then the other one is the one you actually use when you're writing stuff down. Like, for instance, what I'm about to do is see what this radius is 22 or 11. 11. So so what we want is to say, and actually, do we want it to be from here? 11.5, 23. I guess we want to do that one. Let me see what I actually have. And that would be the same as figuring out how big this hole is. So yeah, so we do 23, so it'll fit. So we'll say the notch hole is 22. So we'll So you click enter, then you have to come back around. I don't really get that. And this is going to be 22. It's not clear that this... Yeah, it's the total... I don't know if... Yeah, it's the total clearance add. So it's... If you're changing the radius, it's over 2. Okay. So it's okay. Let's go back and look at this sketch. Where does this get done? I actually love the left click being the pan. That's so much better than the shift. Okay. Okay, so yeah, so we're doing this based on the gears. Well, we have the advantage of knowing what the gear sizes are, but if we didn't, well, let's just still set a stepper to y-axis as being... No, but then the gears would have to be defined in terms of that. So what I think we want to do is we're going to define the two. So and then hopefully when we generate the gear, we can actually set the pitch diameter to what we to the parameter, so that we... Okay, so let's see. How do we do gears in onshape?
Welcome to another onshape tutorial.
Why don't I just search gear, bro? Oh, hell yeah. You can set the module. I set the module to 2. The pitch diameter. Oh, sick. And we can put in a... Nice. Okay. Dude, this is actually... Wait, I think you can do that with... I'm pretty sure you can do that with Fusion. Ugh. Oh, yeah. Okay. So let's... But you can't define one in here. Can you? Oh, you can. Heck yeah. Sometimes you can, sometimes you can't, it seems like. Depth. Oh. Wait, can I actually do this? Can I play around with a gear in a new part studio? Let's, new part studio. Okay, we're just gonna do Alt-C spur gear. Okay, it's going to be, the number of teeth are, wait, it's a module of 2. Oh, wait, what the? It's a module of 2. The pitch diameter is 30, right? No. Is it 30? Hold on. Yeah. The pitch diameter has to be 30 because there's 15 teeth and the module is 2. And wait, can we do the pitch diameter, the size ratio? Module is the pitch diameter over number of teeth. So yeah, if the module is 2 and the pitch diameter, yeah, is then 30. So we want this to be, so yeah, so let's just say small gear pitch diameter, because we only have 2 types of gears in here, and this is going to be 30. I don't know what the pressure angle is, and root fillet. I don't remember what I do. I think I do 0.5. Whatever, we'll leave it like that. The depth is actually true, and I want to make that a gear depth is 5. Yeah, that's actually good. And the question is this. Oh, this is yes. Small gear tooth count is 15. Oh, and they have. Wait, do they have a? Wait. Oh, they have the chamfer too. Dude, okay, their gears are way better than Fusion gears because I think do they have herringbone? Double helix herringbone. Dude, they just have the feature to do herringbone gears. I bet their API, dude. I want to get into feature script now. I bet I'm gonna come up with some nasty feature script stuff. Okay, well, we don't want this though. Center bore, we get a bore diameter. I think I don't want that because I think I'm just gonna add it myself. So this is the whole thing, right? Wait, hold on. This is a pitch, and then the module is 2. The module is, yeah. We could just define another gear module is 2. Okay, I think that's it. So now what we want to do is we want to do all this hub, build the hub. Okay, so now we need to okay, so let's just do this thing. So you sketch on here, normal. Wait, what? Oh. Normal. Let me draw a circle and okay, so we get that tangency, which is cool. I want to know the distance between this and this. Okay, so that's standard. And then I want to know if I were to draw a circle. Oh, wait. Yeah. If I were to draw a circle. Wait, if I change that, does it. Wait, is that a... Can I edit that? Change to driving dimension? Right, yeah, that would be weird. That'd be bizarre as heck. Wait, redo. Or wait, no, wait. Okay, so wait. Oh, so, okay, wait. If it's gray like that... Oh, wait, hold on. Yeah, if it's gray, then it's driven. Wait, is that true? No. Wait, hold on. Let me start from the beginning. Select the sketch pane, circle. We go like this. Okay, now we draw a D here. Okay, it's black. So if it's black, then it's a driving dimension. If it's gray, it's a driven dimension. But since we have the tangency, that's why it was whatever. And it is 25 because it's 2 times there. But so what I wanted to do was I want to get the distance from this. I'm glad they keep that highlighted. Dimension cannot be created between these two things. Okay, wait, what if I just draw the circle that has tangency here, right? Because there's a little bit extra. And then I draw the distance between these two circles is 2. Right, so just to remember how gears work, there's a slight asymmetry in terms of that. I guess it's going to be that point. Oh, wait. Okay. Wow, that kind of looks beautiful. It looks like the sun. Okay. So now we want to take this and we want to extrude it. And the annoying thing is that we're in a new part studio. I wonder if I can just... Like, I want to just take all of these. Hold on. Can I just... move them up here? Oh, that's so hype. And then I just want to add to... Wait, if I just copy them, and then I go into part variable studio and I paste them, dude, this is what I'm saying, bro. If everything was just an expression and you're just passing around expressions, add comment, show dependencies, that's kind of nice. Feature script, is it feature script time? Oh, cool. You get logs about like their rendering or whatever. That's sweet. But I feel like it makes sense to but what do we actually need from here is the question. We want the height because wait, actually, but the height is supposed to be to the end of the shaft. So in the shaft, wait, but the notch. How do I just search my parameters? Create a variable. I mean, oh, oops. Um, oh, linked document. What? Okay, I didn't really get that. So we want to extrude that so that the total gear height is, what does it actually look like? Does that go in there? I don't think so. Can we get a cross section? So we want it to sit above, and we still want it to be 20. So in this channel, you have the notch, which is 2 millimeters. Then you have the shaft, which from the distance from the, is that what we're calling the shaft height? I wish I showed you the expression. Because some of these have expressions. No? Maybe not. Stepper shaft height. Wait, can we just measure it again? Wait, I gotta stop using that as a crutch. This is 22. Yes, so stepper shaft height. This is from the face with the mounting screws on it. So let's just say that. The distance from the top of the shaft to the stepper's face, that has the mounting holes. And so that means that we're going to have, this is 5, that's 2. Wait, we're going to have, yes, it's just going to be 24, which is the height, the shaft height, minus 5. So it's going to stick out 19. And so that means that we want, this to be 19. Okay. So we're gonna say small gear hub depth. Oh wait, we have to do a hash. And this is going to be shaft height minus wall. No. Minus wall minus gear depth. What? Oh, there we go. Sometimes it's not clear like what the enter is gonna do, I feel like. Okay, fine. I gotta stop being so hesitant. Or if problems happen, problems happen. So let's first draw a circle. This is going to be the oh yeah, this is just going to be if we go to this, and we want to know this. Okay, so shaft diameter is 5. Ugh, that's so annoying, dude. You expect to double tab because okay, just open up Excel. Wait, actually, I don't know if I have some. Dude, yeah, onshape. Okay, in Excel, tab brings you over. I don't know why the heck they. I don't know. It's just so silly. So shaft diameter is 5, and then in here, um, shaft, stepper shaft, gear clearance. And then you have to is 0.2. So we go here, dimension this to be shaft diameter plus shaft clearance. Great. Now we extrude this, blind, flip, remove. I always forget that. Blind up to next. No. Through all. Wait, up to next. We do enter. Okay. Wait, this is the top view? Okay. So here we're drawing a sketch. And we need to well, we're trying to do M5, right? So really? M5? Why does that sound so big? Okay. Okay. My bad. My bad. Okay. So, so if we're doing M5, the M5 nuts, and then the I remember it's 16s that you need because okay, and then we should probably write down the distance to
the distance of 5 millimeters. And finally, what I'll do is I will select this line of this rectangle, and I will select this point, holding down Control.
Midpoint.
And then to those two objects, I apply the midpoint constraint. And then I can finish the sketch. I now hit E for extrude, and I drag down this profile by 10 millimeters. If you want to make it a little bit more parametric, what you can also do is construct a midplane between the top of the mounting hub and the start of the gear teeth, and then extrude up to that.
Well, the question is, okay, so let's get down the height here. Okay, so stepper face to shaft notch is 9. So that means that you only have to be 4. But then the diameter of the let's think about this is like you have the gear. Oh geez, that's terrible. Okay, wait, you have this. So man, what do we say? It was 9. So that means that there's 4 left over. So then the notch. From here it was 4. So so if we put the hex nut down 9, or wait, let's say 10. Because what because the hex nut when you measure a hex nut, there's 2 ways to measure it. It's the flats distance, and what's the other one called? Where you measure point to point. Oh, it's just called width across corners. Okay. So M5 hex nut width across corners. And this is going to be 9. Where's the shaft? Okay. So then but the inner, since at M5 the inner should be 5, so that's 2.5. So if we're up 9, 9 minus 2.5 is 6.5. So what does that mean? That means that 6.5. Okay, wait. So so here's the shaft. Here's the top wall. So the notch starts here, and that's 9. And there is this thing. It's irrelevant. We should just ignore that thing. So then, what we're saying is that from the top, right, from the top wall, we have 9 to of, so then there's like a, okay, so that means that, yeah, so that means that the distance between here and here is going to be 6.5 because the M5 is 2.5 radius. So so basically we want to know if 11.5 is greater than 9. And it is by enough. Okay, cool. We figured it out. We did it. So we're good. So where's the 10? Gear hub hex nut depth. Gear hub hex nut depth. Extrusion depth. And this is going to be 10. So it's actually going to be 10, we said. So then this is 7.5, which means that it's 12.5. So anyways, it's good. It's good. But the question is, this distance between of the socket head, dude, can we please? Yeah, I don't know why they wouldn't just. Much better. That's how it should look. Hopefully it saves hopefully it saves my views like this, because this is way better. It doesn't have any of the XL features. Someone just needs to sit down one day and do that. So the socket head OD is 8.5. So this is 8.5, which means that this is 4.25. Okay. So what we want to do is 12.5 plus 4.25 is equal to 16.75. And 16.75 Wait, what are we trying to figure out? We're trying to figure out how much we have left to the top of the shaft. So the top of the socket head is going to be, yeah, 15 plus 4.25 is equal to 19.25. So then that means that shaft height, which is 24, we only have 5 left to the top of the... Wait, the 5 is plenty. Okay. I think 5 is plenty. So we can go back to this, and we can start to draw a line, a rectangle. Or wait, let's do center rectangle. Wait, no. Rectangle. Okay, then this is going to be the flats distance plus 0.3. Wait, let's make that a, wait, oh, yeah, you have to freaking type millimeters. It's so stupid. But, we actually want to make that a parameter. How do I just make a new variable? Wait, can I do it within an expression? That would be kind of cool. So if I did plus hash Oh, you can. Sick. So, hex, uh, uh, hex clearance, hex flats clearance. It's going to be 0.3. Okay. Oops. This is going to be hex depth plus hex depth, hex nut depth clearance. And we're going to say that's 0.3 as well. I don't know if they need to be different. Okay, now we want to say this and this. Oh, this and this midpoint. Oh, that's so annoying. You have to do Alt-C. Okay, so what is ill-defined about? Oh, wait. This 5. Okay, so now we take this. Okay, we extrude this. Remove this. It's going to be the hex nut depth cross corners. Hex gear hub hex nut extrusion depth. Okay, so now I want to draw a sketch on here. I don't get a midpoint here. Is that a midpoint? Oh, wait, maybe I did get a midpoint. Oh, there you go. And this is going to be M5. Wait, M5 whole diam. And it's going to be 5 plus 0.4. Okay, that's it, right? Then you take this and oh, there we go. Select other. So now we need to extrude. Remove. Which one is which is the question. Okay, so this one's the other one. So this one is not. Oh, okay. So it's up to. Then this one is 5. Awesome. Now we want to draw another sketch on this face. Sketch N. And then we want to draw a polygon. Inscribed circumscribed polygon. And do we get this thing? Yeah, we get it. Yeah, we do. Oh shit. We get this. Get this. We want 6 of them. And then we want to take this and this point. It's gonna take a while to unlearn holding control for selections. Then we want to search midpoint, and then it's fully defined. I like that I'm not like messing up a lot. Like I feel like things are actually kind of the same. Okay, so except you don't hold down. You right click, select other, this, and then you do an extrusion, remove, and then I would just want to do up to face, and then I select this face, right? There we go. You could just do up to next, right? Up to next works most of the time. I'm gonna do up to face. Is it done? Yeah, it's done. Wait, so this is what I was worried about. Look how close that is to there. Why is that the case? This is 1.3. That's way less than 4.25. And what is the height of this? I feel like maybe I didn't. Wait, what the hell? Wait, that's only 19. Should I just you don't really want the nut sticking out. Well, you can't have the nut sticking out because then the thing won't lie on there. So honestly, I think you could go down to an M3. I'm gonna check out the M3s. Oh, you know what I should do? This is actually a good idea. Is just sit down in a variable studio one day, open up a blank document, and then measure like all of these, like a huge number of parameters about the parts that I specifically own, because that'll make life so much easier going forward if I just have like specifically the dimensions of all my parts as opposed to just like, I don't know. Okay, so M3s. So it'd be an M3 by 16, and it would be M3 nuts. I feel like this would be strong enough to hold the stepper. They are so small though. Okay, but these are kind of what I'm going to use because the distance, the width across corners is 6 millimeters, 6.1 millimeters, which means that that plus clearance is my insertion depth of the hex nut. So that means that we would be able to lift up that this extrusion. So if we were to go back to this, oh yeah, so we would change that. So it's is it in here? No, it's in here. And we change this extrusion depth to be closer to like 6.5. So that gives us, okay, and then we would change In this sketch, no. In this sketch, no. In this sketch. It's this sketch. And you just want to change this to M5 whole diam. We're gonna change this to make a variable. So that still stays a variable, but we're gonna have set gear hub set screw diam. And this is going to be 3 plus 0.4. And we are going to change, so enter, and then we're going to do this, and this is going to be gear hub set screw diameter. Okay, and then we finish the sketch. Oh, there's no hotkey to finish the sketch. So now we have this point. Min distance is 5.8. That is certainly enough. Oh, and did we change this depth actually? The extrusion depth. Oh, we did change the extrusion depth, right? Yeah, we changed it to 6.5 because the width across corners. Right, so what we actually wanted was M3 hex nut width across corners is 6.2, I guess. Wait. .1. And so what we're saying is it's going to be M3 plus 0.4. And then why is this error? Variable not found. You have to move it up. That's actually nice. Why can't it find it though? Okay. So this is done. This hub is done. But I'm kind of wondering, I wonder if I can do different configurations. I've never done that. We'll watch a video about that. Okay, so let me see if there's such a thing as a so yeah, so I'm so glad we didn't spend time watching that. But what I do want to know is Configurations in onshape. I mean, honestly, yeah, okay.
Configurations in onshape give you the ability to manage variations of a product within a single document using design-driven choices. This streamlines the management, use, and selection of these components throughout your design process. For example, when inserting a configured flange into an assembly, you can select the correct variation of the product by selecting your design requirements, such as nominal size, flange style, and pressure rating, as opposed to choosing from a single complex list of choices.
Oh, whoa. So when you insert parts in assemblies, oh, it generates this drop down that you edit. That's kind of, dude. And oh, that's so cool.
This also means that you do not have to be an expert in manipulating complex spreadsheets to create these configurations. This flange, for example, in a traditional design tool would require 570 separate rows to configure all of the variations available to the end user. Let's look at how Onshape streamlines the entire creation and selection process for this flange.
Oh my gosh, max PSI. Dude, real designers, they have to I want to look up Onshape simulations. I bet there's simulations.
Onshape simulation is fast, easy, accurate, and meaningful for agile product design decisions. This toolset allows you to simultaneously design and analyze assemblies in Onshape's secure cloud workspace with unified CAD, FEA, and PDM capabilities.
Dude, imagine if you had continuous integration where before you could like merge a part in, it had to, dude, I never thought about that. It has to run a simulation and then it has to basically calculate for a certain points or something that the stress doesn't exceed some amount. Dude, that is crazy. I never thought about that before. Continuous integration in CAD, bro. That's so crazy. I feel like very few people do that.
Configurations in Onshape give you the ability to manage variations of a product. Would require 570 separate rows to configure all of the variations available to the end user. Let's look at how Onshape streamlines the entire creation and selection process for this flange. When creating configured products in Onshape, you define the input criteria that the user will choose when selecting a product to use through a combination of lists, checkboxes, and variable input. Onshape process for this flange. When creating configured products in Onshape, you define the input criteria that the user will choose when selecting a product to use through a combination of lists, checkboxes, and variable inputs. Using the list option, you can define a selection of nominal pipe sizes for the flange. You do not need to create every variation of the flange at this point, just the 19 standard sizes for this list that the end user will select from. Once the selection list has been created, any feature or parameter in your design can be used to configure the product. This could be dimensional values.
Okay, so what would I do? But what I want is, I mean, yeah, this is why writing a program is so cool, because I just want to, I want the configuration thing here to drive the values of parameters. But okay, wait, let's just
suppression states, formulas, and even input selections for
features.
I think,
is that what it's doing?
Once the list selection has been created, you can immediately start to see the results of the input you've added to the configuration selection above the feature list. Notice there's no list of created configurations. Rather, you simply make your design-driven choices and instead see the different variations of the product.
I don't see where he's using, because are these
design-driven choices and instead see the different variations of the product. The next selection the end user will make will be to determine if the flange has a flush face or not. Configuring this selection simply requires a checkbox to define a yes or no choice. This feature, while simply changing the suppression state of a feature, doubles the total number of variations of our product while only presenting a single option to the user, as each configuration input works with all of the previously defined inputs. Adding in
okay, so wait, so let's just try to so Configuration variable. Wait. No features are configured. Yeah, that's suppress, add selection to folder, edit. Wait. Oh, wait. Don't we have a conflict here, actually? Gear hub set screw diagram. So I want to undo this. I don't like this. Oh, wait, can I just delete this? We configure part studio with a list. So the configuration name is going to be M3. Configure features. M4 and M5. So wait, let's just start with 2. So select sketches or features to configure. So which one is it? It's going to be, well, it's going to be this. So it's going to be sketch 3 and 4 that we're mainly, and 5. Okay, so let's start with just 1, which is, so wait, okay, so let's go through. So we have M, and then we need the flats distance. Okay, so M3 hex nut flats. That's 5.3. Okay, so what we this is going to be, wait. How do we, how do we configure this? I didn't really get what he did.
Selection process for this flange. When creating configured products in Onshape, you define the input criteria that the user will choose when selecting a product to use through a combination of lists, checkboxes, and variable inputs. Using the list option, you can define a selection of nominal pipe sizes for the flange. You do not need to create every variation of the flange at this point.
Wait, what?
Just the 19
Wait,
standard
what?
sizes for this list that the end user will select from.
Oh wait, oh wait, oh wait, oh wait. Okay. So, where were we? Wait, we're not in a sketch right now. Oh, configuration. Oh yeah, this is gonna be called this is gonna be called set screw size. Default. Okay. So wait, so first we want to edit this sketch. And we want configure dimension. So M3, we should just be able to say M3 minus hex flats clearance. All right, 6. So this is going to be, or plus hex flat clearance. Then this is going to be M4. So let's just change this to be, we can't rename it in here. Okay, so in variable studio, we're going to have to M4 hex nut flats. .8 and then wait, M4 hex nut depth. Wait, do we need depth? I don't know. Oh, we do need depth. And I don't think we have M3 hex nut depth too. So we need hex nut whack. .7. And what did I say this one was? I freaking forgot already. 6.8. And then we want the oops. M3 hex nut depth. Ah, what the hell is wrong with me? 2.3. And then M4 hex nut depth. And let's keep. You can't select multiple at a time? That's insane, bro. What the hell? Oh yeah, we actually have to measure a whole bunch of stuff. There's 3 for each. This is gear hub. Is there a formula? Yeah. See, I wish I could. Can I add the? It's crazy that you can't. Yeah. So my main 2 gripes at the moment are, once you like try to draw a circle, it takes like 1 too many clicks, or like 2 too many actions to like be able to write a variable name. And then for this thing, this whole variable studio is like kind of mid. I mean, I just want to add the column of like what the expression is so I can like see it. And then you can't select multiple of them. It's kind of crazy. Okay, so let's do the socket head. So I'm pretty sure these are M3 by 16s. 5.25. M3 socket head OD 5.25. What did we say the hex nut depth was? 3. Okay, we're almost done with this boring part. We just need the depth. 2.8. M3 socket head depth. And this is 3. This is just 3. And then we just need to do, let's see, we have the flats, the width across. We don't have the depth. Oh, we do have the depth. And then we just need the stuff related to, so we get our M4 by 16s out. .7 M4 socket head OD 7. No. 6.7. M socket head depth. Okay, that's the last parameter, I think. And it's 4. All right. So now we should be able to just change this to M4. Oh no, sorry, M3, M4, and then this we configure dimension as well. And this is going to be M4 or M3, M4. And can I see the value of this? They're not going to tell me the value. Oh, hex flat. No, that should be fine. Can you name this? M3 hex nut depth. Okay, cool. So that's that. Now we need to go to this extrusion, and this extrusion depth, configure this. Okay, that's fine, but this needs to be whack. Wait, M3 whack. Wait, no. 3 flats. And then what do we say? Plus 2. Wait, what is this value as it is? It's 6.5. Wait, what? Extrusion. That doesn't make any sense, right? Because the M5 nut. Oh no, it is the wait, hold on. What is the extrusion depth actually? I believe it's going to be half. The extrusion depth needs to be at least half of the whack. So yeah, so the gear hub extrusion depth must be greater than the hex nut whack over 2. Okay. So yeah, so then that actually checks out. I don't know how I calculated that. But it's 7.8. That should be good. And then what else do we need to oh my god. Okay. And then we just need this sketch configure gear hub set screw diameter. This is going to be okay. 3.4. Wait, we can make this 5.4. 3.4. 4.4. We can just do that. And then that should be fine, right? So I think we're good. Okay, so now what we want to know is... Wait, this doesn't look right. I thought we made that extrusion depth way more. Ugh. Because what's the distance between this and this point? 4.8? The M5 will work then. So yeah, so let's do M5. Great. And wait, let's just check oh, 3.8. Yeah, so wait, but let's switch to M4. Okay, first off, okay, so the extrusion this. +1. Why don't we just make it total? Why don't we just put it in the middle? Isn't that the best thing, to put it in the middle? All right, so we're going to change it to be that. So that actually is nice, because if we put it in the middle, then we don't need to have it in the configurations. Yeah, because you want to keep the number of configurations to a minimum for sure. Okay, so what do? We just delete column. And it's just going to be what? Hub depth, gear depth, hub depth. So it's going to be hub depth over 2. So wait, so let's delete this column. And let's just make so which extrusion was it? So this, no matter what, is just going to be gear hub depth over 2. So now we're going to switch to default, switch to M3. So wait, so let's see, can we get away with this? 4.3. What? .3. Yeah, so probably M4. Okay. Yeah, I wonder if you can add like little tests to like ensure that certain criteria are always met for all the configurations, because you can't just look through them all. So you, okay, so we're done, right? This part is done, and we just want to switch to M4, and then we want to check these distances again. How do you deselect everything? Onshape, deselect everything, keyboard shortcut. I remember I thought I asked this. Escape does not do it. Bro, what? Deselect everything Onshape. Or access. You have to like go out here. I don't. Maybe I just don't know what the Okay, wait, but so okay, we're not done yet though, because we need to now Okay, so we're done with this. We can close this, right? Okay. So now we want to do a mirror, part mirror, feature mirror. It wants to be this, this, this. And the mirror plane is going to be sweet. And now if I do this, oh, that's awesome. That is really cool. So now we need to go to here and we need to put a hole. So wait, so, okay, so this is one gear. And I want to move all these parameters. And I wish I could add an index. I'd like to know how many parameters I have. Okay. Okay, yeah, so this goes back to what is the driver here? The All right, I'm going to open up a new part studio. Can we rename these? Um, so we're going to do a new part studio. And it's going to be, oh, you can move these. You can't freaking move these in Fusion. It's actually crazy. You get Stockholm syndrome from using bad software. You just like learn to deal with it because you got to do other stuff, but it's like it's torture. So this is going to be the other gear or the top plate. We could have this be the top plate. And then so in here, we're now going to create a gear. And let me clean this up so I can write on. What are we doing? So we are basically trying to add a sketch here. Do I have that notch diameter thing? I think I do. Notch height. Can I control F? How does this work? Dude, it just defaults to the... That's fine. That's not so bad. Notch height, notch diam. Notch clearance. Okay, so then what we want to do is we want to do just a stepper notch hole. And then we just want to make this stepper notch diam, stepper notch clearance. Okay, so that's what we're going to do. And then actually what okay, is it in here? Probably in here. Oh my gosh. Oh, I want to look at that sketch. Is it this sketch? No. What is the sketch for this feature? Oh yeah, it's this. Okay. So yeah, so we have let's just say big pitch diameter is 130. But then this is exact. But do we have backlash on these gears? I don't remember. When I did module profile offset. Oh, yeah, so oh yeah, and there's the settings for that. That's so cool. I guess there's configurations, but oh, and it's all done. Oh, this whole that's so cool. Dude, that's so cool that spur gear is just a feature that drives a bunch of it's just a configuration. It's just like any other part. They just have a gear part and then they have a bunch of configurations. This is so much more powerful. So wait, so I forget what kind of for module 2 3D printed PLA gears with a nozzle diameter of 0.4 millimeters, what backlash should I use for printed gears? Okay, so we need to go back to this. And we want to edit this, and we just want to go here, backlash. This is so nice because in Fusion, you can't edit the gear. Once it's been made, well, that's not true, but it's not this easy. So we're going to do 0.2. Okay, and it was fast, too. I remember being kind of slow and... Okay, so so we're good here. Top plate. I'm just gonna make the gear here. So, but okay, so let's put it all in here though. Big gear pitch diameter, and then do we have a gear depth? Scoping, bruh. Okay. Okay, let's just go fast. Who cares? So this is gonna be depth is gear depth. Number of teeth is going to be 65. The module is 2. I like that you can edit both of these. This is pretty cool. Root fillet, that's fine. 0.2. I think we're good here. Oh, and no hole, right? Yeah, so sweet. Now, we are just going to do the exact same thing. I wonder if we could actually make... No, see, that would be the right way to do it, is that... I'm going to add that to my to-do list. That would be really freaking cool. Use configurations to make... Oh, wait, what would I really have to do? It would basically be a matter of forwarding a bunch of parameters. What's up? What's up? Oh, man, I've been going for 3 hours already? Bro, what the hell? What the hell, bro? Okay, so... This is so weird. I don't know why they did this. You gotta, like, update it. Would it actually be faster for me to just do it? No, but it's actually not the same part. I don't know what I was thinking. The gear that mounts onto the top plate is not... The hub is different. Yeah. Okay. I don't even remember this part, actually. It's this. No. Wait, is it? Wait, what the hell? What the hell? Yeah, so we just arbitrarily made the hub diameter 45. So what then? Okay, so now we need to know actually some placement because okay, so from the bottom plate to top small gear should be, I think we designed it so that the gear is up here, right? Is that true? I feel like it is, but is it? We defined the oh wait. Wait, what determined this extrusion distance? Small gear hub depth. Oh, there. See, I don't know why it didn't show me the value. Show me the value. That's so much. Also, these are dependencies. I don't know why it didn't say that. So it's going to be stepper shaft height minus gear depth. Wait, shouldn't it be minus, oh, minus wall? Oh, yeah, minus gear depth. So this does mean that the shaft is going to end right at the top. It's going to be flush. So the distance here then is 19. So what does that mean? Do we have this pillar height thing set up yet? Do we have this pillar thing? So what's going on here? So the total pillar height is equal to top plate, bottom plate distance. And actually we are allowed to just put that as whatever we want as long as it drives everything. So if that's 19 up and we want it to be 31, then gear depth plus big gear hub depth should be equal to it should be equal to the top bottom plate distance, top bottom plate dist minus, and then do we have a variable for this in small gear, which is we'll just add it. So This is going to be small gear depth. And this is going to be... Wait. We have to be careful because... So what we actually want is the gear depth to just be this. Okay. Okay. So what we're saying is it needs to be the gear depth. Yes. Okay. So big gear depth. Wait, no. But there's actually, you have to be careful because there's 5 of overlap. So it needs to be big gear depth is equal to, yeah, top bot minus small gear depth plus 5 or plus gear depth. Okay. Then they will mesh. Dude, maybe it's just that I'm getting better at this. Maybe I'm in a good state of mind, but I swear doing this in Onshape or maybe just doing it for the second time. I mean, the use of parameters is like at such a higher level now. I can think through these designs so fast. Or, well, so much faster than I used to be able to. Okay. So, yeah, it's so annoying that we can't, like, there should just be a button, like, move to, like, I know it's tough, but, like, I just want to move that to variable studio. I mean, what it does is not that complicated because it would just look at the dependence. Well, I don't know if it's complicated, but since you can query the dependencies of a variable, but just by traversing the variables and all that, I mean, it's not that hard. Okay, so what I think I'm going to do, though, is I'm just going to make the gear. So we want to extrude this. So, okay. Well, okay, here's where we'll find out whether or not we're... Bro, what? What the hell? Oh. It's going to be... Okay, so let's okay, so let's do this. Okay, so this extrusion is going to be I don't know why it's not letting me. What the heck? Wait, 25? Wait, 31? Yeah, that's wrong. Wait. No, that's right. Oh, that's only 12? Okay. Is there a reason why we want it to be... Yeah, so let's just make the... Let's just change this to be 25. Wait. Okay, let's think about the assembly. Wait. It's 6. Okay, so we have the bottom plate. We put the stepper on. We bolt it down. We put the pillars. We what is it called? Self-tapping screws in all the pillars. Then we bolt down the top plate into this. And so that's going to be 5 plus 6 plus 6 plus 5, 11 plus 5, 16. So we need a M4 or something by 20 millimeters. I have M5s by that too. M5 by 20. But so wait, so that means that if it's 20 minus 5 is 15 from down there. But the distance between there is 25. So what is the problem? Why shouldn't we do this? Well, one thing is that it was just kind of nice being able to hand tighten or, well, I probably will be able to get my tools under there. So let's just go ahead with that. We just saved 6 millimeters of height. That's pretty sweet. So now we just need to, we're going to make a couple of parameters for, we'll make them like 4.4. We'll use M4s. I mean, it's so inconsequential, I feel like. But basically what we're modeling now is, I don't know where this thing is. I've messed this whole thing up, but well, let's just keep going. So we're going to draw on here. And we're going to draw our, and then this actually does have a through bolt, center bolt. Okay, then we want another circle. Wait, what? Let's just do this too. Yeah, it's kind of interesting because what we really want is a function that lets us but whatever, we can just remember. What? Wait, is that already a thing? Oh, is this a comma? Random. Where did I get 10 from? I'm gonna try to go look at that. Okay, I can't get to it. I can't get to it. Um. Oh yeah. Okay. So wait, in the to do for this design, that before I forget, is let's just make sure that we have the cable notch hole in bottom plate and mounting holes in bottom. Okay. All right. So this part is done, and big gear hub. Oh, that's okay. That's irrelevant. Okay, so now we're finally ready to this is going to be big gear pitch diameter. And then we are going to draw another circle. Not like that. We're going to draw another circle like this. And this is going to be also Q. This is going to be small gear. Wait, we can just delete this. Nice. So, yeah, so this is right. So we're good here. Now we just need to draw a circle here that is click, 1, and backspace, and then this is going to be a stepper. Okay, and then what we want to do is draw a circle here, and then those are ding 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 ding. Let's turn off the fasteners. 3.2. I like there's so many things about this that I like. So, okay, it's 15 and 15. Is it gonna be circular pattern? Wait. Does it have to be from there? Whoa, whoa, whoa. Oh no! Oh, nice. Wait, but... Oh, there we go. That was weird. Okay, so what I want to do... I want to circular pattern this. Wait, I'm getting confused. Try one more time. No, no, no. I want to change this. Oh, there we go. There we go, bud. We just need to make it 4. Where does it show the... Just check something. It's hard to see those. Is that gonna work? That's gonna work. That'll do, bruh. Okay, so now we can put a notch. So we need to make a tangent plane or whatever. So wait, is this part done? Oh no, it's not done because we're gonna do a wire here. And what is the front? This is the front, right? So yeah, okay, so we need to do the bracket. So the bottom plate mounting bracket. Wow, it's been 3 hours. I said I was gonna be totally done with the design by now. Okay, wait, so can we go to an assembly file? So we can close this, right? Yeah, let me just do this. So we can close this. We can just. It's weird because you can't close them, you have to delete them. That I feel like you probably can close. Unpack, rename, move to document. I don't know. Okay, so let's just do a new assembly. And we're gonna just try to put the we're gonna put this and we're gonna put this in. And then if I wait, assembly 2, can I you can do it on parts, but you can't do it on assemblies? That seems kind of weird. Okay, so we want to join. We're gonna mate. Yeah, it's gonna be this with that. Now I wanna re-enable this, and I wanna solve. Or I wanna flip it. Wait. Reorder items. Okay. Oh, that's so nice. Oh shit. Wait, so let's try it again. Wait. Wait, how do okay, wait. Here. Do I have to make these parts in an assembly? Maybe I do. Maybe I have to do that first. So first, so now, okay, now let's do a little test. Wait, what happened to the other one? Why are there only 3? What the hell? Somehow I deleted it. I wish we could just group all these together. Move to new subassembly. Okay, but now if we do this. Oh, nice. That's cool. Okay. So now we should be able to do this, 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 this. Okay, I'm pretty sure that's it. Can we do interference detection? Can we get a section analysis? There's got to be a section analysis tool. This was 10 years ago. Wait, why don't we get... Why don't we get the planes that I want? Who cares? That looks right. Why does it look so fuzzy? It looks weird. How do you disable it? You just go back to this? No. Oh, you turn off section view. Okay. So now we want to add in small gear. Yeah, that looks good. What's up with that, though? Why does it look conical here? Wait, can we, oh. It's just at an angle, I guess? I don't know. Wait, but actually... Wait, we're just trying to measure. We're not trying to do anything weird. $2 mils? That's fine. Okay, so let's just do the top plate then. Yeah, I don't have a good intuition for when to make a new part assembly. Oh, shit. Okay, now we gotta draw... And I kind of want to be able to use my old, the top plate that I have now. It's just so awkward that it's like off by 8 millimeters. Like, hey. It's these are motors that go on a drone. They spin really fast, and you put a ball in there and it shoots it forward, and then it can turn like this. It's supposed to be able to turn like this too, but it'll take a while. I actually redesign it. How can you do it? Pretty good. Pretty good, yeah.
What do you teach in practice?
Dan's like, yeah, CNC machine. You guys better go walking?
Yeah, we're gonna go get it.
Alright.
We're just in Saturday.
So you just took a press forward here from the rolling starting.
Yeah, oh, cool. I love that. It's just there.
Oh, wow. You took a pump into that rolling starting? I know we talked to the back.
I don't think we went to that road garden. I think there was another road garden.
Yeah, the two most popular places for pumpkins was the rolling starting and then out east on the some people went all the way to Stanford.
Oh, wow.
Hey, I think that's still there. Oh. Hey, Diana. We're already at the. Oh yeah, this all.
Okay. So basically, let's look at the other design. How do we just open up the top plate? Dude, this design is so fucked up. It's like everything is out of reference. Open source? What the hell is that? Oh. Oh, that's just gonna open yaw? Oh, wait. Oh, pitch. That's what I mean. So let's just activate this. Is this its own file? No. So this is literally just 2 sketches, which is nice, but it's also like, and these are not mirrored, right? Can you see that? So I don't know why we don't put these out as far as we can. Like we want to maximize our area. So what is sort of the maximum distance that we could? Okay, so Okay. So realistically, if we wanted to make them as far apart as possible, we want to, then basically what we want to know is, so yeah, so we just want to go look at the sketch related to, so turn off this freaking cross section. We're trying to find not these holes, but this. Dude, what the hell? There we go. So this is 100, and then was the pillar its own? The pillar, this made it a new part, so we want to look at this sketch too. Okay, so we have 100 plus 12.5 is the distance to the pillar, and the pillar's diameter is 12. So we have, so this is going to be 112.5, and then this is 12. So that means that so that means that 106.5 is, so let's just say it's 105. So what we're going to do is we're going to define we're going to draw this, which is going to be oh, but this uses a parameter from here. All these pillar things are whatever. It doesn't matter. So now what do we want to do is we want to add mounting holes. We want to add a mounting hole that, okay, so let's just define a circle like this. What are these? The 6s, the 15. Didn't we do 4 of them? Did we only do 2 of them? Ay, 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 this is crazy. Yeah, the question is really is like, because it's an unknown of whether or not we can do it. But let's just say that, okay, so we're gonna do M6 hole. And it's just gonna be 6.2. 6.2, is that kind of tight? I don't know. So this could be, right, 106 minus 3.1 is where it's tangent. Or 112.5 minus 6 minus 3.1. Oh, yeah. Okay. So now we just want to give like 2 more millimeters of clearance. Dude, it's so annoying. 2, let's make it, if it's an M6, oh wait, so we should just think about it. So basically what we want is, we want the width across corners of an M6 nut. So the M6 hex nuts here. Okay. Yeah, I gotta make some food. I'm hungry. Okay, so we have these dimensions, and what we're trying to say is that it needs to be, so this number minus blank millimeters. So that's tangency. Wait, but the overlap, no. We need this minus, okay. Needs to be minus M6. Okay, so this is where, and then we want probably 1 more millimeter of clearance. Or 1 millimeter of clearance. That's probably fine. So then this is where Oh, is that exactly 100? Dang. So, okay, so that's kind of cool. Okay, yeah, I think I want to build yaw only. Okay, let's make this construction. And then we're going to draw another circle that's like up here. This is not construction, but it is equal. And then the distance here. Oh, wait, yeah, so wait, it's not vertical. So we need to take this and delete it. And make this 100. Oh, so now we get an angle. Wait, how do you do an angle? Oh, wait, no, we can do a height. What's the distance in the actual one? 15? Let's make it 20. Dude, I like that they give me these mirror lines all like for free. Um Okay, so yeah, this distance is the same as this distance, so we're good. So okay, so the plan is that we mirror that. And that gives us, gosh, it's hard for me to think of the pan or the tilt design and the yaw design the same. So I think I'm just gonna basically just go for maximizing flywheel. Oh yeah, we gotta build the flywheels and everything. There's way more parts than I thought. Um, so what we're gonna do, we're gonna mirror those across. So the idea is that we're just gonna take Bruh, this woman comes over. They come over like 45 minutes early. They bring up this disgusting pug, and it's just peeing over all of our shit right now. It's just going around peeing on different little things. That I feel like I'm responsible for this stupid fucking animal. Now it's licking its pee. That's licking its pee. Yeah, it's a pug. The mental faculties of maybe a fish. Dude, I don't know how people out of all the dog breeds are like, I would love a pug. So we're gonna take these. Should we just instead of doing a mirror, should I just do a circular pattern on those? Let's undo that. So in this sketch, instead of the mirror, we can't undo though. Is that for real? How do I rotate specifically 90 degrees? If I just click on them and do delete, do we think that's gonna work? Okay. So what we're gonna do actually is and we're gonna do four of them. Wait. Yeah, this is right. Okay, now I wonder if I can just select basically that whole... Yeah, I wonder if I can invert a selection. Okay, I feel like I should just design around this then. So in pan only, that means that gives us 200 from the mounting hole. Okay, so should I just start designing this thing? We'll draw a sketch on here. Let's go to probably the one part that still works in this thing, which is wherever it is. I don't even know where it is. It's definitely not that. It's gonna be... It's this blue part. Oh yeah, I can't do this. Okay. I feel like I could do I feel like I could do, okay, wait, let's just see here. Okay. So what happened? Should we just do half then? Why don't we just build half and then mirror it? And then this needs to be 7. Okay, so this is the only thing that's not a wall because I remember this geometry was special. But honestly, do we even need this? Those magnetic encoders are like... Yeah, I think I'm going to skip the magnetic encoders and we could just come back to it because those features are just they're not crucial dimensions. So what we're going to do is we're just going to build Jesus. Dude, this thing is just humping the ground, bro. Dude, right? Disgusting. Oh my god. I don't know. It's just like, dude, it's just fucking I just fucking can't breathe and it's humping the ground, bro. It's just like what the fuck? Oh, dude, worst dog breed, bro. Chihuahua. Bro, it's like, why not get a dog breed that's like, exactly. That's what I mean. It's just like, it's just been bred to be the worst. And I like dogs, but like, I like dogs that are actually good. Like, this thing is just like, all I know how to do is eat shit and hump. Come here. Come here. It just doesn't know. Just staring at me, dude. God, they're just so dumb. Okay, so wait, are we on a sketch? Okay, so wait, this is the top of this? Yeah, I kind of placed the gear weird, but that's fine. All right, so we're gonna. Wait, what was this? Oh yeah, okay, that's fine. But what was is not fully defined? Wait, what? Okay. So now we can draw in here. And let's see, how do we want to do this? Those holes are going to be there. Wait. Shift 7. Or wait, actually, I want to look at the front. I want to look at the top. Okay, so this is the back, I guess. Bro, I can't focus with this fucking whatever. Hold on. Okay. So wait, what we want actually to do. Right. Okay, so we need to make this a parameter, right? So this is going to be top plate mounting hole distance from center or something like that. So like top. We're letting in our house because she's doing us a favor, but it's like things got piss all over its feet and it just walked into our house. Wait, what did I name this thing? Top plate mounting hole. Great. And so this needs to be top plate mount hole distance to center. Okay, so now we're using a parameter there, which is good because what we need. Okay, so the theory of mounting holes. Let's say we have just a rectangular piece of plastic. And we have two circles. And these are going to be 40 apart center to center. The question is, how big do you make the rectangle? For these M6s, okay, actually, I'm just going to ask ChatGPT. No, it depends, but if I have, if I'm doing 3D printing and I have M6 holes that I'm going to be using nuts and bolts to clamp two M6 on different plates down to each other, how much clearance do I need on each side of the bolt for it to be like structurally sound? No. Okay, clearance is not the right word. What I mean is, no, what I mean is for the bracket that's going to be connecting the two. How much distance do I need of material around the hole, like to the edge of the bracket, for it to be strong? Oh, dude, hold on. Whoa, 1.5 to 2 times the bolt diameter? And what is that based on? Okay, so let's make a parameter for that actually. So we want basically, what did it call it? Edge distance ratio. Mounting hole edge distance ratio. And this is not a length, it's a scalar. And it's let's just make it 1. Okay, so if this is 6.2, do we really need to do that? I feel like using this is going to be harder than anything else. But so, fine, let's say that then this distance needs to be 6.2 times 2, and same with this. Okay. So I'm going to just do this in a new... part studio because I'm having trouble. Okay, so here's the plan. So this is going to be defined. The width of this is going to be defined in terms of the hole diameter. Okay. I'm just going to do it on here. This is stupid. Why would I even do this? Okay, so we're going to draw... So we have a sketch on here. We're going to draw a rectangle. It's like this. And the distance from, wait, do we even get this? Can I do this? But I don't get the circles. I don't really get how this works. What if I just, and then this can go to there. It doesn't actually matter. And it's not Q. So this, can this move up and down? No, but this can move side to side. And so what we're going to say is that this distance, first off, wait, we didn't do this right at all. We're going to get a rectangle. It's going to be like this. The distance, oh, wait. The problem here, because this is the top plate, it just makes it more annoying that we're doing it at an angle. Oh, you know what I could do, though? I could draw everything relative to, no, whatever. So we'll just do the trigonometry ourselves, I guess. So this is 20 up. So the first thing we need to do, is make the distance from here to here M6 times oh wait, what we could do instead, let's do it like this. Edge times M6. Oh, this does have a coincident on the is this the center point? Did we draw it here? So we want this to be wall plus oh yeah. What? Dude, why do they make these so small? It's like you can't even edit this expression. Okay, onshape has some donkey behavior in it. Wait. I think that did not do what I wanted. Why does it show me the whole thing, but then when I edit it, it gives me like 12 characters? Okay, this is not right. This is wall. Wait, but is this symmetric about this thing? We actually don't want it. Well, wait, the distance from here to here, and the distance from here to here. We want it the other way around. It makes it so hard to see. Wait, I don't understand. Why don't we just delete this? What? Oh, yeah. Oh, wait. Okay. So then you take this and you extrude this by wall. Wait, this is going to be a new part. This is going to be wall. And it's the other way. Okay, then on here. All right, we're starting to get the hang of this thing. Okay, now the height of this thing. We can make this really low. There's no reason why I picked 30. Okay, so let's just do yaw-only height. Bro, that looks clean. So wait, the distance between the center of this. No, wait. 11. Wait. Let's just look at the sketch. Is it this sketch? $11.2. I feel like maybe this whole edge ratio thing was kind of a mistake. The point is to know how much. Okay, wait. So this is driven by. Okay, so I actually want to add a second set of holes. Top plate mounting hole just center. So we'll say this is, we'll rename this. So top plate outer. And what we need to know is what can we get away with? If we look at the original model, dude, all of these designs are totally messed up. But, oh yeah, we still need to do the notch and the mounting holes on that side of it. Jesus, there's so much left to do. But how far in can we go? Well, if this is 60, then that's the only thing that's stopping us. So we can, okay, so we have the 250. And then we have the 60. And so it just has to be, so the inner mount hole must be to center, must be greater than 30, and less than 125. Well, really 100. So let's take, because you want it to be, I mean, the strongest is when you have it as far apart as possible. But maybe that also means that you're printing stuff too big. Um, let's just make it at 40. Let's just do 40. So what we're going to do is we're going to go back to this sketch. We're going to draw a construction line to here. And we're going to draw another circle on here. Okay, and then the distance from here to here is going to be inner. Wait. Oh. No, you basically can't do that. So that means, okay, there's a bunch of radii, or there's a bunch of diameters. There's the pitch diameter, then there's the, what is the name of the diameter for a spur gear where it's not a spur gear, where it's the very most outer footprint of it? If you were to circumscribe a circle so that it covers all of the gear, what is the name of that? It's just the OD. So the OD of the gear, right, you have to add the addendum, whatever. All right, use. Okay, so it actually has to be 135 over 2 is what? 67.5. It actually needs to be greater than 67.5. Because otherwise to mount something onto the top plate, you would need to take off the gear, which is like really annoying. Okay, so we're gonna change that. So first off, let's undo all of this so that this hides. Okay, now it's back to being fast. So we just need to go to this, and we need to change this to be M6 whack over plus clearance. So it's going to be gear or big gear, yeah, big gear OD over 2 plus M6 whack over 2 plus clearance. Wait, so should we just define a okay, if I'm using an M6 hex nut that has a width across corners of 11 millimeters, what's a good amount of clearance so that I to put around it so that it can whatever. I'm just gonna do like let's just define it. It's like so easy. Let's just say M6 whack clearance, and this is gonna be just like 2. So then so this needs to be, and it needs to refer to the big gear's outer diameter. If I have a module to 65 tooth gear, how can I calculate the OD? Yeah, it's okay. It's 134. Teeth plus addendum times module. Teeth. Okay, so teeth is going to be, oh wait, we're gonna have to that's the number of teeth, then plus addendum times what? Times module. Wait, 134? That needs to be over 2. Wait, this is the so oh wait, what did I have it the other thing named as? Top plate inner mounting hold just to center. So it just needs to be big gear outer diameter over 2 plus M6 whack over 2 plus whack clearance. All right, nice. Okay, then we just mirror this along. Wait, why isn't our line? Why don't we have our construction lines? Whatever. Wait. Is that what we want? We don't want it to be on that line. We want it to be forward, so we want to change the angle. Okay, so what we actually want, we're going to delete this. I'm going to delete this. I'm going to draw a circle. That's going to be driven. But the distance to here, oh no. This distance needs to be inner. Okay, now what is it just the where's the little X? I wish Sketches gave you a little. The hell is the X? I should have just mirrored the extrusion. I always mess that up. Yes, finally, steampunk. Copper gear vinyl. I don't know. So, okay, but what we actually want to do is we want to make that way wider. So if we want to go back to this sketch, we want to change. So is this just a random dimension? So we want to say. So wait, so then this dimension needs to be driven, right? What happens if we change this to 21? Or like 30? Or 50? At some point it caps out at 45 degrees, right? Okay, so what we want is top plate mounting hole to x-axis. And so right now it's 20. What is it in the feeder? Is that where it's at? Is it this? Can we open it? Bro, why can't we open it? What the heck? Oh wait, finish edit in place. Wait, how do you... What the hell? Why isn't... Wait, how do you even... Something's bugged. Because middle mouse button is not doing what it's supposed to. Oh my god. I'm gonna restart this thing. Dude, look at how many parameters I have. This is insane. Oops. Alright, so I just want to reopen it. I just want... What is it that I want to know? I want to know the width. Okay. Part of the nice thing though about doing a project this intricate is that there's so many things to do that you can usually find something to do while you're waiting for your print. Like there's software or hardware or whatever. There's other stuff that you can do. Actually, speaking of, okay. Yeah, see now that middle mouse button is working. 70 across. So, um, we could try it. We could try it. 35. It wasn't even that bad. Oh, whoa. I kind of love that, but like, no, I don't. What? You select, hold on. Wait, remove. Wait, cancel. Oh no. Wait. Okay, that's fine, but what I'm trying to do is it this? No, it's not that. It's gotta be this one. But why don't we get... I don't get that. Can you not do it? No, there's absolutely no way that's true. Here, I'll prove it. Hmm. So then why is... So wait, can we just delete this? This is totally useless. Oh. Oh. Oh, okay. Nice. I mean, I actually like it the other way around, but, you know, it was unintended, so I didn't really... Okay. So now... Okay, so it's 100 to that thing, to the center of the circle, right? The mounting hole. What is the name of that parameter? Top plate outer mounting hole distance to center is 100 millimeters exactly. So then it's going to be 100 minus what, 11.2? Yes, this is, and then this. That's 11.2. So what we need to is then we're going to extrude this thing by 100 minus 11.2, and that'll bring us to the center. So we're going to go here. Wait, is that? And this is going to be whatever it's called, top. Just to center. It's so funny because it's easier to remember the numbers than it is to remember the names. Should we make a measured thing? Okay, wait. I'm gonna keep it like this, but we're gonna go back to this is called yaw-only. No, that's over. Oh, minus, wait, no, what? — 9.4? My math is so wrong. What? This is 100. Oh, wait. What we actually want to do is not that, because that's the wrong thing. What we need to do is we need to go back to, we need to take this distance Is that right? Yeah, that's exactly right. Because that's like, that's definitely the difference. So you need to make this a parameter. Oh, I'm starving. Okay, so can we just, I thought there was a button that you could like make it a variable. That's actually nice. Copy table. That's pretty nice. It's not like an expression or anything, but that would scare designers. Okay, frick it. I'm just gonna copy this. Wait, I don't actually know if this is convincing myself, because I mean I know I just checked the distance of this to this. It's 9.4, which is like exactly right. But okay. So the distance from this hole to the front of this is 11.2. And the distance from here to here, oh, is that what it is? Let's go to sketch 4. The distance from here to is 90. Okay. He's 90, bruh. I see. Is there just a huh. Okay, fuck it. We're just gonna do wait, actually, can I extrude to plane? Why don't I just extrude to plane? That's what I'm gonna do. So instead of this, we're gonna edit this, and it's going to go to face. I want to select Extrude to plane. Up to part, up to vertex. Okay. Okay. Great. Is this all? No, so now we need to draw on here. Okay. And we need to draw this a center point. Okay, so the question is, first off, look at how wide apart this is. This is a huge, huge print for these motors. I don't know why. So maybe I should make it 30. So if I were to do this is so great though because it is parametric. So if I just went in here and I just changed the top mounting place hole to x-axis distance to 30. And then we went back to top plate. That's got to be 78? Oh, yeah, because the holes themselves are. Let's make it 25. Yes, the problem is we have kind of this is almost done. So yeah, perfect. They're 50 apart. Yeah, I love that this is all about inequalities, kind of. Oh, and then let's Oh, I think it was this that had a ton of bodies. We want to group them. I'm hella hungry, bro. Yeah, I think I don't want to do this. Oh no, you know what I need? I need an assembly file. Okay, I'm back. So, and then this assembly is just the stepper. I don't really get what they want me to do here. Like, I want to hide these. I want to fold them down. Like, I don't really get it. I think move to document is probably what I'm. But okay, so we're going to create a new assembly file. And it's going to be we're going to name this the flywheel assembly. Okay, so we need to insert this. Okay, then we just need to import, and actually I'm going to go to GrabCAD and download. I don't even remember where I put these things. But yeah, we should just put it in here. Wait, where did it go? Wait, no, see, this is the... I didn't want this. Oops. Wait, I don't get that at all. How does the import system work? See, when you do this, import to this document. I don't know how you end up managing. You're gonna have like 1,000 of these. Whatever. So you... Oh wait. Um. Okay, but now we need to offset a rotation about Z. I can't tell because of this highlighting. It makes no sense. Presumably that's correct. Let's try it with plus 90. Or let's try it with, wait. All right, let's just say, okay. Okay, that is right. Great. So now we need another assembly file called top assembly, I guess. Because you can't import the thing in here, or you can. All right, whatever. I'm just going to do this again. And this is going to be called top assembly. And then I'm going to insert the top plate. And then I'm also going to insert the BLDs. Wait, can I not? Oh. So what? Basically, we just need it to be wall plus whack over 2 plus whack clearance. But they're not M6s. They're like M3s. Right. So if this is the outer wall, this is the inner wall. We have 5, and then we want and then can I? Oh, see, that's what I'm saying is why. How come I can't? Wait, if I do this, does it move the rest of them? No. How do I? Position 2. Switch to this means you I imported a step file into onshape, and there's a bunch of bodies. And the problem is when I try to move one of the parts, the other ones don't move. But is there a way to just group them together? Right click on your imported. Select the parts you want to move together. Click the group button from the toolbar. Oh. That's a good one. I like that one. What are you doing, step file? That's pretty good. Okay, so in the assembly, you select all of these, and then you do Alt-C group. Oh. Mate error. Is there a group? Is there an idea of a group in Part Studio? My guess is no. Yeah, so there's no group thing in Part Studio. Let me just look up grouping.
Next up, let's discuss the group command. As mentioned previously, the first steps to an assembly are normally inserting your first part or parts and then fixing one part. In general, it's best to only ever fix one part in your assembly, then insert and group or mate the rest of the parts into place. In this example, we have a pneumatic cylinder that we designed inside of a single part studio. When we insert this into the assembly, I can click on the entire part studio from the list, and all parts modeled within the part studio are inserted at once. After we insert all of our parts, we need to fix one part. In our case, that will be the pneumatic cylinder barrel. I can right-click and choose Fix. So now that we've fixed our first part, we need to start constraining all the other parts in the assembly. Because this pneumatic cylinder was built together in the same part studio, all the parts automatically come in the correct position in the assembly, but they are not constrained. You can see they're free to move in any direction when dragging. Many of these parts do not move with respect to each other. You may be tempted to fix each one of these parts, but this is not the best technique. Here we can click the Group command in the toolbar and select all the parts that are fixed with respect to the cylinder barrel. All of these parts do not move, so we can use the Group command to group them together. Simply click the Group command and select each part that you would like to group together. After clicking the green check, all of these parts are grouped. You can have as many groups in your assembly as you would like. For example, the cylinder, rod, piston, and other parts of this assembly can also be grouped together. These parts move, but they all move together as one unit. Now that we've created the two groups for this assembly, we can use one cylindrical mate to mate everything together.
Okay, so why didn't mine work? What? Mate cannot be added between member of same group. Wait. Wait, dude, I am so confused. No, this is stupid. Wait, how did we even get this in here? Oh, we're in an assembly file. Oh, okay, so what we want to do is probably... So we have one fastened thing, but we want these all to be a group. Okay, cool. So now on the top assembly file, can we... Let's just insert it again. Flywheel, bldc. Okay, so now I say I just pick a number. I'm being so certain. I'm taking so long on this. I need to make some food. All right, I'm gonna take a break. locked me out of here. Mom? Mom! No, come here. Come here. Someone locked me out of here. Yeah, Daniel kept locking me. Okay, I'm back. But I need a minute to eat. I'm pretty sure. I'm pretty sure the distance from the center of the BLDC to the edge of that mounting bracket is 50. Or so 25. So then I need to make it 30 plus clearance, so it's like 32. I like that they have good educational content.
Old CAD is limited by old technology.
Everything is moving to the cloud. And for CAD to not do that just doesn't make any sense.
Do I keep going through this pain, or do I at least try something new?
When something better comes along, we're going to try it.
Onshape is really allowing us to get back to being what it is that we're passionate about, being engineers.
Young blood with the marketing.
Old CAD.
What is this?
It used to be that you would design under one roof and then manufacture under one roof. What we've seen is a lot more specialization. Expertise has become fragmented, and as a result, each of these people need to coordinate and work together in the design process. They can be across the state, across the country, across the globe. And so people need tools to be able to interact and communicate. We took the opportunity to look at how the CAD world had evolved, how product design had evolved, and how the computing infrastructure evolved. And we decided to hit the reset button on product design software.
Onshape is building a new generation of CAD, one that's designed for teams to use. Everyone on the team can use it anywhere, on any device, anytime.
We're capitalizing on the platform, the cloud, mobility, and redesigning essentially what CAD is to help people design products faster, easier, and more affordable.
20 years ago, when we built SolidWorks, we built CAD on the modern computing platform, the Windows PC. It runs only on that computer. When it comes time to work as a team, users have to use all these schemes to copy files, check in, check out. It's kind of a hassle and it costs them time. Today, CAD still runs on that Windows PC, but people are used to using their phone, their tablet. People are used to working on multiple computers and going into a web browser.
Dude, I gotta be honest. People laugh when I'm like, I would love to be able to use CAD on my phone.
Teams are built up and torn down quicker. There's a lot more collaboration. Tends to be a lot more contractors, a lot more consultants.
And so the rest of the computing world has changed a lot, but CAD hasn't. And it's time for CAD to evolve.
You know, users, they're like all of us. They're tired of trying to figure out what's the login password for the data vault, because I don't use it all the time. And when I get the assembly, all the links are broken.
License fees, installations, license managers.
Do I have the right version of the part or the right version of the assembly?
I visit CAD users. Years ago, I talked to them about modeling cool shapes and cool products. But in recent years, when I visit users, they're talking about all the hassles of CAD. And it's time to get rid of all that.
Users today expect that we should just be able to access information and share and work with other people real time.
much like the way that Google does for working on a Word document. We've done that for the CAD world.
We get to collaborate on the same geometry, which was never done before. We have found ways to break down our modeling paradigms, our assemblies, our models, our features, so that multiple engineers can collaborate on the same feature, which was never done in CAD before.
I don't even know what cuts forth is.
We love innovation here. I'm making something that doesn't exist. That's what we live for. If you don't like change, you're not going to be happy here. Because when something better comes along, we're going to try it. We make products for the power industry, brush holders, shaft grounding solutions.
Depending on the size of the generator that we're making parts for, any delay of 10 to 24 hours is going to cost hundreds of thousands of dollars. And we have a very small window in which we can get in there and do maintenance and install the parts that we design. If you start with a tool that's prone to errors and prone to delays, you're just going to have that ripple effect all the way down the stream.
I use SolidWorks for 15 years, and so I know CAD. The problem...
Hello. Okay. I am back. All right. Add some more water. Wait, 35 to there? No, that's not right. What the heck am I talking about? This can be wall plus M6 clearance. Is that what I M? No, what is it called? To edge. Edge. Oh yeah. All right, so this is just gonna be M6 hole because the ratio is 1. But then you need that seems pretty good to me. So what are we saying is that, hold on, I gotta switch over. Okay. Okay, so what we're saying is that the corners of this rectangle, and then what we want to know is the distance between the holes. So let's just look at the mounting bracket. And we want to know the distance between so if we're doing it like this, wait, center dist. Oh, nice. Oh, that's so nice. Oh my goodness, that's so nice. Okay, so we want this to be 30. Let's see, am I still getting volume? Okay. So top plate, this is 30. Oops. This is also 30. Right? Right? It's gotta be. Oh, but what's the size of this? It's 3 in diameter. Oh wait. How did we get this? Wait, this is driven by something, right? Oh, yeah. Oh, yeah. Why is that not valid? What? Wall plus... I don't understand why that's erroring. It's so... I mean, this is so bad. These error messages are terrible. I mean, it just says error. Escape doesn't seem to deselect. Okay, now I want to look at top assembly. Oh. I feel like it's harder to navigate. Okay, so that's right. So now we just get to mirror it. We finally are ready to mirror it. What the? Does this one have the joint too? No. Wait. All right. So now we just have to do the feeder. I need to get my broccoli. Oh, and we need to design the flywheel. Just that simple couple fillets makes this thing look so much better. What the hell? Oh wow, you get the yeah, 52 parameters. Wait. How do I want to do this? Because I really want to make it correct where the bolt is put in tangentially or perpendicularly as opposed to just like a hole through it. So like if I draw, okay, so let's go enter, oops. And then let's say, what is that? What is that? I don't understand that. In Fusion, you could absolutely. Okay, so what geometry can I use? That's the thing that I don't understand. This is the most confusing part of this thing that I've run into. Is like I'm working on this plane and I want to. So I want to select this whole thing. Oh, there we go. So now this is a midpoint. Oh wait, I'm not in the sketch. Wait, what? I thought I said... Oh. Oh, that's weird. Oh, so you don't get this point, though. Wait, but you could say this, right? Okay. That's so strange. Wait, we don't have... Oh, there we go. Okay, so project is becoming easier to use. But so what I'm saying is that right here, this circle is going to be perpendicular to, if you were to draw a line from the center to this thing, it would be perpendicular. So I think what I need to do is basically we want to figure out how long the arc is and then draw that out. Let's say it's 10 degrees. If it's 10 degrees of the circle, and the diameter is 250, then that means that 1 over 36, is that right? Wait, that's not right. 10 degrees, really? Let me go look at the existing one. Where are those freaking brackets, bro? I don't even remember where I modeled those. Yes, the radius, but how long is the distance? Wait, if we were to look, is there a button for normal? I don't know. Ah. Oh, wow, it's 40 degrees. Okay. So if we want to, we're going to rotate it by that many degrees over 2. So we're going to make a plane that's that over 2. Is that right? All right, well, let's try it. So now that I know what's going on here, I'm going to undo this, and we're not going to use this sketch, and we're going to delete the plane. Let's just delete these. Hello? Dude, what the hell? Okay. So we need to... Oh, that's useful. P is for plane. Line angle. Plane, point, line, angle. Okay, so let's say that it's okay, let's just say it is 40 degrees. Wait, is that right? Can I just get the length of this arc? $81. See, my math is wrong. How's that 80? I'm getting like 27. How is that possible? I have a circle with a diameter of 250 and then an arc that is just a portion around the circle, and that angle is 37 degrees. And basically I want to know what is the length of that arc. Oh. Wait. Why do you multiply by... Wait, no, yeah, that's just the diameter times the Oh my gosh, I was confusing diameter and circumference. Silly me. Yeah. I was confusing diameter and circumference. Okay. Okay, so let's just try. So, okay, so if it's going to be 40 degrees, then we want it to do 20 degrees? Oh, nice. Oh, that's so nice, dude. This is how it should work. Okay. But so we don't want... Okay, so what we actually want is we want to rotate the other one. So we want to rotate this by, what, 110? But then we don't get an offset. But that's okay. So we'll do this, then we'll do plane again. And this one's a offset plane. We take this, and then it's going to be plate diam over 2. Okay, now we can hide this. How do you hide? Okay. So we're going to sketch on here. And then what we want to do is we want to project. See, this is what I don't understand. Why doesn't it give me... Whoa. Wait, N should take me... Okay. But that's what I'm saying, is I don't get this.
Use and intersection are two powerful sketch tools that often need to be more utilized. Each tool allows you to take existing geometry into an active sketch. The created sketch entities are parametrically linked to their source part geometry. This means when the part changes, the sketch entities created with use and intersection update automatically to reflect those changes. So what is the difference between the use and intersection tools in a sketch plane? The difference between use and intersection is that use converts edges and face silhouettes to the active plane, while intersections project faces onto the active sketch where those faces cross through the sketch plane.
Was that it? What the heck? I don't really know why I was able to... Okay, wait, but you know what we can do? We just draw lines between them. Wait, why does normal not take me to where I want to be? What the hell is going on here? Wait, dude, we put 4 of them, actually. This is gonna be... Actually, we'll do it from here. So what we're going to do is we're going to now do a circular pattern. Wait, we're going to yeah, I think we do want to do a circular pattern. And we want to do one circular pattern and then another circular pattern. Is this really 5 mils? Why doesn't this work? There we go. I don't know what happened. Oh no, yeah, that's weird. Okay, well, whatever. Now what we want to do is we want to do wait, we want angle to be 40 and we want 2. Please tell me we can do nice. But wait, that's not. That's going to be too big because I was assuming that was the corners, but not the holes. But all right, let's keep it for now. And then I just want to do another circular pattern. So okay, so uh Dang, bro. I'm getting real parametric. And it's crazy because now those holes are tangent. That's sick. I just feel like I'm always disoriented. Okay, so now what we want to do. Wait, should I draw this sketch on here? No, I can't do that, but oh, this is so hard. You have to. It's that time of the day. More parts. Proto boards. Proto boards. Come get your proto boards. Wire. We got wires. We got wire. Specifically 16 gauge wire because all I had was 22 gauge and that just can't handle the current. Here's one. Oh god, please tell me there's another one. Oh, nice. Okay. So we need to solder these together. And then we will have a Pico debug probe. So that's cool. And then there's one more thing. Oop. It is just a pack of screw terminals. I like that they gave me a lot of 2, and that these are rated for like 10 amps at like a crazy voltage. So that's all good. That's all good. Okay. Oh yeah, I forgot. I really want to do this. Let's see if we can do that. No, that's not going to work. So we need to on sketch. Yeah, that's a good decision. Okay, so we need to do this. Okay, so let me just start with sketch. Can we project this? Why not? Uh, well, anyways. We can just project. Oh. Okay, but wait, how did I actually do it? Why is this such an annoying part? Okay, whatever. Let's just try something else. Okay, so we at least added these. But now we need to add first off. Um okay. So the flywheel diameter. We're just calculate the flywheel diameter. So the distance to this top plate Okay, so that means that. Okay, so you take that number over 2. So 82.449 divided by 2, or wait, minus 5 over 2. That's the flywheel radius. So it's just 82.449 minus. Wait, but that's not right. It's plus. If you were to draw a line. Is that what I mean? Wait, let's just draw a point there. Wait, where am I? Okay, so what we want to know is the distance between the center of this Okay. So it's going to be that 449 over 2 minus 2.5. Okay, so the thing that I want to do is okay, yeah. So wait, was it really? Wait, no. 82. Oh, 82 plus 30. Yeah. Okay. So what determined the whole distance to there? Where's the mirror? Oh, there it is. Oh, yeah. Okay, wait. Let's also edit this to be... Well, whatever. Okay, fine. So, whatever. The flywheel... how should we have the flywheel? What is driving the 112? Okay, so this is just going to be that 112.449 over 2 minus 2.5. Wait, what? Wait, really? How big is the flywheel right now? Oh, wait, this is times 2. Is that true? Oh, wait, yeah, I did this last time. Yeah, you don't... It's not minus 5. It's minus... There's going to be 17. There's going to be 22.225 minus 5 is 17.225. So this over 2. So let's go fix the variable. Wait, I think it's just... Seriously? What the... Dude, I hate this thing. It's somehow they still have it so bad. Okay, nice. Very good. Okay, we're sort of at the second to last part. Wait, what does F do? What does just F do? Does F do something? F is a zooming operation. I don't know. I don't really want to do that. Ugh, I kind of don't want to go through building that thing again. I kind of just want to work on the Raspberry Pi. Get that Rust encoder thing working. I'm gonna Okay. And then we really got to build a hopper. Okay, so I say the next thing to do, this is an assembly file. Oh. Wait, in the... Wait, what? Oh, really? Oh, how do we do this? But then offset. Can I click on a face? It should be 19. Oh wait, along Z. But we need to flip. What the hell? Wait. Wait, did I not do that right? Well, it wasn't doing anything. I'm silly as hell. Okay, so wait, hold on. We want to mate? Oh wait, can we... This we want to fix. Oh, that is the shaft. Okay, so what we're gonna do is we're gonna turn off this. Mate. This. To... Okay. There's got to be a better way to do this because this is really brutal. Oh, that's nice actually. They tell you what's locked down and what's not. Wait, what? I swear there's a faster way to do this, man. Okay, well, I think we're good. Has degrees of freedom, but it's just a rotation. So we get a full assembly. And now this turn, no wait, this move, we want to fix it. I don't know. Nice. Okay, is there motion links? Can we just watch? This was 3 years ago. Too Tall Toby.
Hey, what's up everybody? Too Tall Toby here, and in today's Onshape Quick Tip, we're going to talk about recreating some of the mates from this assembly. Now, in our last video, we showed how we were able to take this assembly from SolidWorks, export it using pack to zip, and then import it into Onshape so that we can continue working on this project in Onshape. This assembly in SolidWorks has a lot of mates. You can see there's a lot of mates here, and ultimately what these mates are doing is they are allowing us to turn this tuner, this is a guitar tuner, so that peg up top will spin and tighten or loosen the string on the guitar. Well, this is a lot of mates here in SolidWorks, and unfortunately, none of those mates came across into Onshape. So now the question is, how can we quickly recreate that environment in Onshape where we go to turn this tuner and the gears all spin and everything works the way it's supposed to work in the real world. Well, we can do this actually pretty easily in Onshape by identifying which components are intended to move together. And what I mean by that is this component here, kind of this outside housing of the assembly, is always going to be moving with this upper washer, this upper bushing, this upper threaded part, and then this nut part here. There's several parts there that will always move together. And similarly, if I hide that housing, we've got this internal component here, this screw and this gear, and then the peg up top, which will all move together. And then we've got these remaining components that you can see here on screen, the tuner head itself. There's a couple of nylon washers here, the spur gear, and the piece of hardware here, this machine screw that's holding everything together. Those are all going to move together as well when we're mating these components together. So what that means is that we can utilize what's called a group mate in Onshape. So you can see we've got this option for group, and with group, what we basically say is that all these components will always kind of be locked together or will move together. So you can see we were able to select those several components there, and when we hit the green check mark, if we move any one of those components, they all move together. So let me use Control Z here to undo that. Now, I think that this component is going to become the foundation for our assembly. So I'm going to go over to the tree here and right mouse button on that component. That's that kind of overall housing. And from the right mouse button, I'm going to choose Fix. That way, this component is no longer able to move around when I go to drag it. Let me also hide that component so I can see some of these internal components. So now what I'm going to do is perform another group command. I'll pick this component, this component, this component, this component, and this component. And then I'll hit the green check mark, and we can see that now all of those components are going to move together. Let me do a Control Z to undo that movement. And then I'm going to once again perform a group command. This time, this group command will be on this component, and this component. And now whenever I go to move those components, we can see that once again, they are grouped together. They will all move together. So now I will once again do a Control Z. And now it's really just a matter of us getting in here and adding some mates between these components and their mate connectors. So I'm going to show that housing once again, and I'm going to go to a mate command. Let's make this one a revolute mate. So we'll choose here from our mate types. We're going to choose the revolute mate, and that revolute mate is going to take place here between this end face of this component and this circular edge on this component. Kind of bring those two components together so that they essentially are related to one another, coplanar on these end faces, and then concentric. I'm establishing a concentric mate between these two components. And now I'm going to do something similar here with the with this component, and with maybe what I'll do is I'll relate this to one of these internal components. So let me hide this housing here. I think what I'll do is I'll create a relationship between this component here, this threaded kind of sleeve component here, and then the peg, which is rotating. So let me just get a quick measurement here. The measurement from this face to this face, if I just look down here in the lower right corner, I can see that distance is 10.2108. So let's make sure that we kind of remember what that distance is. Now we're going to go to a revolute mate. This is going to take place between this face and this face here. And we're going to say that that's going to be at an offset of negative 10.2108. And there we go. That creates that distance dimension between those two. And when we hit the check mark here, we can see that now this component is also set up with a revolute mate so that it's spinning correctly. This component here is set up with a revolute mate so that it is spinning correctly. And now the only thing really left to do on these components is go into a gear relation. And with the gear relation in Onshape, what we do is we pick two existing mates. So I'm going to pick that first revolute mate, and I'm going to pick that second revolute mate. And I'm going to say that that relationship is at a relationship of 0.053 to 1. So I just type in the 0.053, and this is going to be going in the reverse direction here. And now we can see that when we go to spin one of these components, we get the results that we were hoping for. You can see that when we spin the one component, the other component moves. The only problem here really right now is the alignment of these teeth. And so if I go in here, let me just reset both of these revolute mates, make sure that they're kind of back to neutral. And I'm just gonna go in here and edit this revolute mate and just kind of adjust the secondary axis. Sometimes you get lucky here. Yeah, like in this case, I was able to get lucky there, and I was able to get those to line up. And what that all means is that now if I were to go to a animation of one of these mates, let's say I go to this first mate here and I choose to animate it, I can actually see what this thing is gonna look like as we are turning that tuning key. So we can see here that Onshape does a really nice job of allowing us to use the animation option. Let's increase this instead of 360. Let's make it 360 times 4 for the total rotations there. And then let's play this thing. And there we can really see what this is gonna look like as that gear is turning. We can change the angle of it. This is something that I really like in Onshape. Hey, if you like looking at this kind of stuff, be sure to hit the like button on this video. I think this really makes Onshape a great tool for kind of validating your designs and making sure that all of your mates are set up correctly. But this I think looks great. And so at this point, I'll stop that animation, and I think I'm now ready to show that housing and move on with my changes to this design, or maybe even reuse this tuner in a future design, because now I'm confident that all those mates are set up and work correctly. You can see that instead of having that huge stack of like 30 mates, we were able to accomplish the same exact thing here in Onshape, just using a few.
Dude, yeah, SolidWorks is for bumpkins. SolidWorks is donkey. Okay. So this rotates and this rotates. So that means, but where are the... We have this. And we have this. Okay. Wait, what was it called?
Remember what that is at 108 when we hit the mates. That first revolute, the gear relation in all.
Wait, how do I know? How do I play it? Okay. That's as good as I'm gonna want it. How did he do that? What was that nudge thing he did, which was super weird?
Onshape, what we do is it in rep 5 3 to 1. So I just type in the 0.053, and this is going to be going in the reverse direction here. And now we can see that when we go to spin one of these components, we get the results that we were hoping for. You can see that when we spin the one component, the other component moves. The only problem here really right now is the alignment of these teeth. And so if I go in here, let me just reset both of these revolute mates, make sure that they're kind of back to neutral. And I'm just going to go in here and edit this revolute mate and just kind of adjust the secondary axis. Sometimes you get lucky here. Yeah, like in this case, I was able to get lucky there and I was able to get those to line up. And what that all means is that now if I were to go to a animation of one of these mates, let's say.
That's silly as hell, but we're not gonna do it. We don't care. Wow, so we gotta print 1, 2, 3, 4, 5. Well, actually, the gears. Wait, hold on. Did I ever? Yeah, I did. So we are gonna need to print that gear. We're not gonna need to print this gear. Oh wait, yeah, we are. I think this height is different. Yeah, so we need everything on here needs to be printed. Okay, so now we just want to. So this is the assembly. This is starting to look pretty good, dude. I feel like I might call it and print, and then tomorrow I can add the feeder. I can do the feeder and I can do the bracket, the mounting bracket. Cool. All right, I'm done to call it. That's 8 hours. It's not bad, but I was kind of goofing off for a little bit. Okay, so what do we want to do? We want to take this part and we can just export it. Okay, wait. So let's so to rename these things. Where did this come from, actually? Oh, this is here. That's the one thing, is export's a little bit slower, but I mean, it's not a big deal. I kind of want to check before I do this top plate thing. Is between there and there is 200, right? So, but let's go back to oh, 184. We might be able to swing it. That's a problem for another time. So I have this design. It's really this design. And I'm redoing the entire thing from scratch in Onshape. And this is what it looks like so far. So we're getting close. There's a lot of features that are new that are nice. My favorite is some of the just the like little touches of fillets. These holes are done immaculately. They're also a lot more symmetrical. So I'm hopefully like this, because the thing is, when I was designing the past, I sort of just put the holes for the part that I'm making, but now I'm trying to maybe standardize it. And then the crowning achievement of today was really that look at all these variables we have. I mean, Onshape nudges you into doing better design because it's so easy to make parameters and variables. I really like how easy it is to deal with variables. Because otherwise I just hate using them. If the friction is high there, then I just copy the number. But then everything breaks. So this hole to this hole is 200. That's 154. Oh, you know what you could do? You can make this L or whatever, this part go forward a lot, and then you could use both of them. You could use both sets. And if you use both sets, then it doesn't really matter that the stepper motor is hanging off the edge there. But basically, the problem with this design is that this extra whatever, what is it, 16 mils? I don't really know what it's the distance from here to here. Yeah, 17. And if we could just get that on the other side, because the problem is, okay, wait, do we have the center point? 67 to here. Oh yeah, this is 67. This is 83. 83 minus 67 is 16. Yeah, so exactly. So if we could just get, so that's the minimum amount of distance increase between, not between the holes though. But between the Yeah, basically, if you made this part move outward by 17 millimeters, then you could have a symmetrical top plate, which is way nicer, because there's so many problems that I was running into with dealing with the fact that I was indexing on holes that were like off center. Like if we look at it's probably on this design actually. Is it? Okay, you can't really tell. But yeah, this. Wait. Wait, let me look at this. Right, no, it's just about the. These holes are centered, but then this top part is not. Okay, so I feel like I should start with the feeder. Oh, but we need to actually design the flywheel. And then, okay, so wait, I'm pretty sure we have a flywheel assembly. So we just need to put in the collet and all of that. So, so I want to insert. I have to import it. Standard content. Oh, interesting. Okay, so let's just do it one at a time so that I don't go too fast. But it's going to be the collet assembly, and it's going to be the. I wish I got a preview, but I'm pretty sure it's this. Import to this document, combine to a. Okay, why not? And we'll just move it over to the side. I don't really know if this is the right way to do things. Okay, so here's our collet. So we want to join or mate. We want to mate this to the top of the shaft. Wait, how does it actually go? Let me go look. Oh wait, can I look from here? Okay, it goes collet, then it goes flywheel. Wait, I thought there was a bottom washer. I must never have put on the bottom washer. Well, let me just look at the parts. Let me just look at the parts. It's easier. So we have the oh, maybe the washer's in there. All right, I'll take it apart. Okay, I'm almost to go to the bathroom. Okay. So yeah, so we have this the collet, we mate the collet to the shaft thing. So wait, is this the assembly file? Did we insert a document or a thing? We don't get P's, we don't get planes. Oh yeah. So wait, so we want to insert the collet. Wait, what? Oh wait. Is that right? I think that is right, actually. I think there is a small gap. Okay, and then the washer. We need to go to import. Call it bottom washer. And let's actually just import all of these. Okay, so now in here, insert the bottom washer. And how does this go? Basically, this goes no. Wait. That goes. Oh, it's so hard to get this. Wait, why don't I just turn off the... Oh, we need to group these together, dude. This is so silly. Wait, are these all just freaking... Oh. Okay, if we mate that to that, and you flip it, and then you want to offset it Z by like minus 0.2 or something like that. We can turn back on this shaft. Okay, now goes the flywheel. So now we want to just make a new part studio. I'm going to call this flywheel. Okay. Okay, so let's get it. Let's hop into here. And I wonder... Oh, the problem is I have no idea where I defined this crap. So let me just get my calipers. Oh, wait, why don't we just look at the flywheel? Honestly, there's some things that are just nicer about Fusion. I don't know what specifically, but it's probably just because I'm so used to it, but I gotta say the left click to pan is huge though. That they totally caught me with that. Okay. Here we go. Yeah. And then 8.25. Okay. Or yeah, 8.25. So okay, then oh wait. Wait, no, that's the shaft, right? Or it's not the shaft, but the okay. So let's finish that. And then this, oh, then we hole it. Okay, so it's 18. Wait, why how did I not get 18? Oh, I did get I got 17 and we're making it 18. Okay, so okay. This is a flywheel shaft diameter. Then we extrude this face by flywheel depth. Then we and then flat, and then how much is that? 12. I hate that it brings you to the top every time. Or wait. Okay, that's our flywheel. So now in this assembly, we're going to insert flywheel. Okay, and now how does the oops, what the heck? Okay, so we're mating that with, is this the right way? No, it's definitely the other way. I didn't do this right. Okay, so wait, let's cancel this. Let's go to this. It's this. And we want to flip it. But then we want to move it up by like, can I inspect it? Top washer, bottom washer. The distance between here and here is 8. So then we just want to move it up by 8. So we're editing this. Did it flip around for us? We want it like that, and then we want to move this up 8. Okay, I'm pretty sure that's right. Okay, then we insert the flywheel. Nope. Wait. What the heck? We just do I. Wait. That actually might be right. Now we need, call it top washer. Where is it? Oh wait, what the heck is this? Why don't we just do this? Nice. So now, if we go to full assembly, we should see the flywheels. This thing is badass. This thing is so badass. Okay, so now we have pretty much everything. We just need the last 2 bits. And then I can finally go inside. Okay. Okay, are we freaking ready for this? We're gonna go to the top plate. And then we're gonna draw a sketch on here. We're gonna hide this sketch. We're gonna hide these sketches. Okay, we want to draw a sketch on here. What is this? I don't like how it oriented this thing. You gotta be careful of the gear. Okay. Maybe we should just design it and then join it. That makes way more sense to me, but then you kind of have to redo all of this. So let's see. If we look at how I did it, It's kind of funny how I did it. Starting off with this. Okay, I'm gonna. I actually like this document thing. I thought I was gonna hate it, but it's actually not so bad. You just leave all the stuff that you don't care about over here, and then you just keep all the important stuff in the front. I'm not going to do this for real. I'm just going to Okay, so maybe... Okay, wait. We're just going to do this loft thing, and then I'm going to go, because it's getting dark. So, and the mosquitoes are coming out. So all we want to do is just try this center point loft thing, because I don't even know if this is how you're supposed to do it. So, feeder. I just made a thing called feeder. And we have this cube. Okay, now we make a sketch on here. Oh, what? Finish this sketch. Now, we draw a sketch on here, normal. Okay, we don't get a midpoint. Is that true? So how do they expect me to do this? Do they expect me to do it this way? I don't know. Wait, but if I do a line from here, oh yeah, I do get it. So it's not like you have to go diagonal to diagonal. Anyways, we're going to draw a circle here, this, 25. Now, we're going to draw a line. Now, how are we doing this? We're going to draw a face on here. We're going to draw a sketch on here. And then we're going to project this and this. Oh, wait, it's not P, it's U. Okay, now we get these points, but we don't get this point. We need to click on this point. Okay, now we need to make a line. Oh, wait, no, wait. We did this wrong because we actually want to do plane. Oh, wait. No, wait. We're going to do plane. And then we just want to click this and this. Line angle, make it mid-plane. Okay, so now we have this plane. Actually, were we already there? We were already there. Okay, well, be that as it may, we're going to make a sketch, normal. Okay, we're going to take this, this, and this, and we're going to use them. Now we're going to draw a line that goes straight up. And a line that goes straight out. Okay, now what we want to do is we want to make a tangent arc from here to there. Okay, now we want to take this profile and this profile. We want to finish this sketch and we want to loft. And we want to loft it along a path, and that path is this. And let's just click enter. And okay, great. Let's go because remove. Nice. Awesome. Pretty cool. All right, so that's it. I'm gonna go inside and we're gonna maybe try to get this Pico working.